Okay. So, thank you all for joining us for this webinar, regional webinar in the African region. I'm very pleased to welcome you on behalf of the IAG for this International Geomorphology Week, where there's lots of webinars going on in lots of places all over the world. There's 10, in fact, going on this week. We're about halfway through, so today's Friday, and the other half of the webinars are going to go on Monday, Tuesday, and we have International Women's Day as well on the 8th, and there's going to be a workshop to celebrate both International Geomorphology Week and International Women's Day. So plenty of things going on. So if you feel like connecting up to any of those other webinars, please do. This is the third year that the an International Association of Geomorphologists have been running this, and it's so far the first few webinars have been just as successful as in previous years. So we're looking forward to being able to carry this on to next year. And if you have ideas for next International Geomorphology Week, don't hesitate to get in touch with us, and we want to make this not just the IAG doing things, but for groups around the world to have little events in their areas, in person or online or whatever. So if people are keen and want to do something next year, then we'd like to hear that, and we can support you in any way we can. So to give you a bit of background on the IAG, we support national groups. So our membership is via national associations, of which I'm sure some of you are members. And we have working groups that work on specific topics. We provide grants for geomorphologists, young geomorphologists usually, to attend conferences, and training for young geomorphologists as well as promoting geomorphology in general throughout the world.
Thank you so much, Susan, for introducing not only myself, but the African webinar as well. My name is Renée Grundling, and I am the Southern African Young Geomorphologist Chair, as well as the Early Career Representative on the Southern African Association of Geomorphology Council. So today we'll just be speaking on promoting geomorphology in Africa, as well as just using social media to help that. So we are quite fortunate to have quite a few African scientific members. That's part of the International Association of Geomorphologists. We have quite a nice representative going on in Western Africa, but in Southern Africa, we have one organization that encompasses at least the whole SADC region, including South Africa and our neighboring countries. So what I want you to keep in mind while viewing this presentation is your audience. Who are the people that you would like to influence, and who influences you? Are you part of the audience, or are you the person that's behind the camera that's sharing input as well as educational content? So just in general, if we look at the scientific members, we influence our audience. And who's our audience? It's specialists, consultants, but we also have our early career scientists. We have postgraduate students, and that's why we have our young geomorphologist groups. That's also part of the IAG. Furthermore, we need to remember that there's a whole public sector outside of our scientific network groups. We also have secondary and primary education children, early geomorphologists, if you can look at them in terms of geography in the grade school levels already. So about 60% of the world uses social media. That's about 26 million users in South Africa alone. It's quite a lot. So social media can be used as an educational tool. It's not all negative. So you'll see a QR code on your screen. and it'll be in certain slides as well. If you'd like to follow the SAYG or the Southern African Association of Geomorphologists, you are welcome to scan that as I continue. So our first platform is social publishing platforms, and this is your standard website. We all use them, we all know them. It's the blogs, the websites. It's things that we use just to quickly Google something and look something up. It's also a place where we share our mission statement, our constitution, and share about events in our scientific network. We also have social bookmarking sites like Pinterest. These are sites or platforms that you use to share certain types of information, and you can also group them, boards and pins, for example. Here we can see meanders and wetlands, volcanoes. It's something that you use to encompass all different types of illustrations and images. Now, Instagram has been a part of the social media community for quite some time. It's a place where usually photos weigh more in terms of its usefulness. It's also grouped in terms of certain interests. So, for example, we have a beautiful photo that was taken by one of our members, and in the caption, we give some geomorphological information. What do we see here? How did the landscape form? And we give additional sources for further reading. So just in general, our audience are usually more your early career scientists types of age ranges. We also have student age ranges. But what we really saw with Instagram is that our posts, even though it's beautiful photos, they don't do well in social media. Something called Reels does better. So what are Reels? Reels are short videos. And Reels was basically Instagram's answer against TikTok. Now, TikTok is a newer platform, but very popular. It uses short videos to convey information or just to share life in general. It uses trending sounds, trending music. It's short and concise, usually for a younger generation, high school learners, students, and so forth. So we challenged ourselves to be part of this platform. So that was a very short video, just an introduction on malachite. It was 23 seconds long, and yet not even 100% of our users actually watched the video in full. So it just shows that videos that are shorter than 6 seconds long does better on these platforms. So again, you have to know your audience, you have to know your content. Otherwise, it's just a waste of time. Now, if you go back to our specialist users, our scientific members, we know that LinkedIn is the best platform to promote basically our geomorphological work, our careers, and just in general to share a bit more professionally. Again, you have to know your audience. You won't be able to share that TikTok video on LinkedIn and have a better response towards it. So how do you influence the audience as a whole? Well, in our case, we saw that Facebook worked the best. Here we could make pages, we could share our interests, we could share posts, our photos do well, our videos do well. Not only that, we can be part of groups, for example, a teachers organization on geography. Here we can answer questions, we can share our knowledge. And we also see that this is the platform that has the most users over different age ranges. So if you don't like social media content, then you have to create your own. But where do you begin? It is such a difficult thing to start with. Again, keep in mind, who do you influence? Who's your audience? So this was just a quick Google search where you can see a bunch of interesting sectors in South Africa, and then also you can have a look at the Environmental Days calendar. And this is quite useful because it's something that everybody can connect to. It applies to a lot of people in general. So for example, World Wetland Day, it was the 2nd of February. World Wetland Day is part of the Ramsar organization and the convention. They have their own official website where you can download content readily made and you can put this on your platforms. There's worldwide events, and we had local events in South Africa as well. And this is a primary education based. So you literally use a paper box and you create a catchment, and children can physically look at this catchment and use their imagination to see what is a catchment and how does it affect them personally. But do not forget about your specialist audience. So plan a conference. We have presentations like this one, workshops, field trips. These are very valuable. Even though it's every 2 years or 4 years, this is where you network with the people in your career and where they get to see your research as well. So without further ado, I would like to invite you to our Southern African Association of Geomorphologists biannual conference that will be held in September in Hogsback in the Eastern Cape in South Africa. Thank you so much, and I hope you enjoy this presentation.
Good morning, everyone. I'm going to make a presentation about a work that we did recently on modeling subsidence risk with Sentinel-1 data in a particularly subsidence-prone area in the southeastern part of Nigeria. I'll take you through a little bit of background, the data and the method used, as well as the results, and I will present some conclusions that we can draw from the work. So, what's the background? In terms of we all know that subsidence and essentially land deformation has a significant social, economic, and environmental impact. And land deformation can be attributed to a number of forces. Natural process can bring it about. And also a number of human activities, urbanization, groundwater extraction, oil and gas exploration, especially in the southern part of Nigeria. And in recent times, sand mining has also been contributing to land deformation in the area. And this issue of land deformation has been exacerbated by extensive sand mining activities along many of the rivers that are draining into the Atlantic Ocean across the southern part of Nigeria, from Lagos down to Cross River states in the eastern part of the country. We see this activity going on. Then also right in the Niger Delta region and across the area, the geopolitical zone that we refer to as the South-South and the Southeast part of the country, there is a lot of oil and gas exploration activity going on. And with increasing urbanization, we all know that sub-Saharan Africa and other part of the middle and low income countries are going to be the most urbanized part of the world in few decades to come. So this extensive urbanization and urban sprawl is creating a substantial pressure on groundwater, which has led to extensive and increasing groundwater extraction. And these we know will have implication for land deformation. So if we really want to, if we do not understand this pattern, the pattern of this land deformation, then there is a problem with providing effective land management, resource planning, and also in terms of disaster risk management. There are recent cases of building collapse as a result of location where those buildings were built without proper. Oftentimes, people attribute it to poor construction material, but also we have found out that land deformation and subsidence actually contributed to some of these disasters. So why did we thought about this? We situated this particular work within the SDG 11, making cities and human settlements inclusive, safe, resilient, and sustainable. So this work actually focus on the target number 6, which is to reduce the number of dead, the number of people affected, and also protecting people who are vulnerable from losses attributed to disaster and so on. So we know that there are traditional methods of monitoring land deformation across the world. However, many parts of Nigeria, which I can talk about, we know that the cost of this equipment, the maintenance of the equipment, the area covered by this monitoring exercise, and also the regularity it's a problem. So most times if you go to any of the agencies or ministry and department that's supposed to do this work, you will hardly find any data in terms of land deformation subsidence. So we need to start exploring other options. And good enough, we have the techniques. The remote sensing is a variable tool to use for this. It can cover large area. The regularity is there for consistent coverage over time. And then measurements can be at a very high resolution, so which can give us a very good idea of ground surface changes. So with this work, we set out to model land subsidence risk with Sentinel-1 data. And in order to achieve these, we looked at modeling land displacements across the study area, develop a subsidence risk map, and then examine essentially exposure index, in the sense that we try to look at how many people are at risk of subsidence in the study area. So how did we do this? To start talking about that, let me first of all provide a little bit of a background about the area we looked at. We looked at the area spanning between Akwa Ibom State, the southeastern part of the country, Abia State, Cross River State, and Ebonyi State. The map here provides a kind of visual representation of where these states that I mentioned, where they are. The area belongs to the tropical monsoonal climate, bimodal rainfall, and that's extensive rainfall throughout the year. Then the drainage, the area is drained by the Cross River, this river right in the middle here, and it belongs to the Niger Delta Basin, as well as the Northern Gulf of Guinea drainages. The area has Calabar as one of the major cities. Then we have Iyo also in Akwa Ibom State as some of the major cities in the study. So giving us an idea that whatever we found out, we can relate it to where people are and try and understand the exposure and risk. So we selected this area because it's an area that has been reported in literature as being prone to subsidence. So with this understanding, we set out to acquire the data, we processed the data, and did some other geospatial analysis. So the processing of the data is quite, it's not for the faint-hearted, I must say, because the data is not too complicated. The techniques are already there, but you need to get yourself familiar with it, and you need to have the kind of computing facilities that can help you achieve this. So from looking at the perpendicular baseline, we selected the data with the lowest perpendicular baseline, and then we ended up using the one for 2020, 4th of January, and then 2020, 4th of March. So that gives you an idea of the regularity of the measurement that is available. So once the data is acquired, we set up to process it using the open source software. I hope you guys can hear me and you can still see me?
Yep, it's perfect.
Okay, because at times you get locked off and you don't know. So we had to do the pre-processing, co-registration to make sure that the coordinates are actually in line with what is real on the ground. Then we do the interferometric processing, the phase unwrapping, and then the geocoding to make sure that the data after processing is now possible to use it within GIS platforms. So from there, from the GIS platform now, we're now able to calculate the subsidence exposure index, which is now used for that processing. So what are the results we got from this? This is the displacement map showing where do we have subsidence and where do we have a kind of uplift, upward displacement in ground surface. So the blue areas signify places where we see upward displacement, and the red, the darker the red, the higher the downward displacement. On average, we have negative 0.013 meters displacement across the entire area, and around here we can see from this we can see it along the border of Akwa Ibom and Cross River State on the eastern end. We can see a kind of tract of land which are showing downward displacement, and towards the northern part of the study area we can see more of upward displacement. So this shows that different areas experience different kind of displacements. However, towards the southern part of the area studied, there seems to be more downward displacement, and at the northern edge we have the upward displacement. So using this, we divided the area into two, where are the places where we're seeing uplifting and where the area we're seeing subsidence. More of the area witnessed subsidence over the period that remember, we looked at a 3-month period. So we have two classes, more of the area, close to 60% of the area are experiencing subsidence. And we can see substantially these areas are more, we can find more of those areas in the southern part of the study area. And on average, the subsidence is about, for this 3-month period, it's an average of negative 0.039, and while the upliftment is 0.0. And all these units are in meters. So this gives you an idea of the level of upliftment, upward displacement, or downward displacement for the study. So to dig in a little bit, because whenever we do something, we have to place it in the context of how does it affect human beings, since our target is to look at this work from the context of the SDG 11 and target 6. So we computed the exposure index, which is basically, we partition the area that are experiencing subsidence and focus on analyzing that within the context of population that are within this area. So for the entire area that are witnessing subsidence, we found that there are close to 4 million people are living within this area. And based on this population, we classified the area into 3 groups or 3 classes using the Jenks natural break. So we have the low, the moderate, and the high. So to complete the exposure index,
2 minutes left.
2 more minutes. Oh, okay. So this shows, we can see here, this is Calabar, and this is one of the major roads and the communities along the major road. And to give us a little bit closer view of what is going on, this is Calabar, one of the major cities in the study area, and we can see along the riverbank and some parts of the city And then towards the northern part of the city, we can also see the high exposure index. So with these, we can conclude that remote sensing offers great improvements with remote sensing and improvements in high performance computing. There is an opportunity to actually do a regular monitoring of land displacement across different parts of the world. From the study, we found out that each population are exposed to this subsidence risk, and downward displacement is much more common than upward. Few areas are actually at high risk, and our takeaway from this is that there is need for geomorphologists and other scientists, technical experts to embrace remote sensing and geocomputation and actually doing this kind of work, since the traditional method, especially in this part of the world, is challenging to execute. So the process that I've just taken you through can be automated. So which means there is an opportunity to actually turn this thing to a kind of to create a regular framework for which a land displacement can be monitored. Thank you very much.
Thank you. So good morning, everyone. It's an honor to be part of this webinar. First of all, let me introduce myself. I'm a master student degree of Geomorphology and Environment in the Faculty of Humanities and Social Sciences of Tunisia. The subject of my presentation is Geoheritage Inventory and Geotouristical Valorization of Toujene, Zmertene, Tebaga of Medenine sector in the southeast Tunisia. This presentation will be divided into three main parts: geoheritage components and specificities, then geoheritage inventory, and geovalorization of this inventory by geotouristical mapping. So in the introduction, it's necessary to introduce some fundamental definitions, which are geodiversity, which is known as the abiotic diversity, including geological and geomorphological processes, landforms, etc. Geoheritage also can be applied to geological sites with significant scientific, cultural, aesthetic, and educational value. So depending on geoheritage components, it can be inventoried into geosites that can be conserved and valorized. So as you can see here on this map, the study area is part of the northern Zahar Matmata plateau. The majority of it belongs to the delegation of Toujene, governorate of Gebes, and the other part belongs to the delegation of Benekdesh, the governorate of Renée. Geoheritage components are based on geological specificities, where the lithology is very various, from the upper Permian of Tebaga to the Turonian, with a lacuna between upper Triassic and upper Barrenian. It's necessary to mention that Tebaga is the unique outcrop of upper marine Permian in Africa. Depending on depth values, two types of structure can be identified. The first is the monoclinal structure or cuesta, where strata layers are inclined with a dip from 2 to 5 degrees west to south. To southwest, and the other structure is the polar structure, which is ridge of Tebaga, where sedimentary series are inclined with average dip of 30 degrees to the south. So there are two angular unconformities here in this area. The first one is upper Permian and Draconian. As you can see here in this picture, which is the angular unconformity of Halgejmal. The second one is the upper Triassic, and Draconian angular unconformity called of Sidi Bouzaba here in this area. There are many tectonic movements in the study area, like faults, as you can see here, especially in the Tebaga sector, and we can find also some sedimentary faults and slumps that we can clearly see here in the village of Toujene. So, depending on lithology and tectonic features, main structural forms are the main cuesta, double cuesta, the main cuesta of Kefensura, Jebel Zmertene, formed by massive dolomites of Turonian on the non-resistant layers of Cenomanian, and the second cuesta is formed by dolomites on the non-resistant layers of Draconian. In this area, as you can see, the second cuesta is qualified as an ordinary cuesta. However, in this area, it becomes qualified as a false cuesta because it is formed in angular unconformity. As you can see here, we can clearly see Draconian layers are on the Triassic layers with an angular unconformity. This cuesta of Kefensura is in contact with the Tebaga of Medenine ridge, and we can clearly see it here from this picture where the ridge of Tebaga is sorry. We can see also the angular unconformity of Halgejmel from its north part. Sorry, what I passed. There are also various quaternary forms and deposits, like quaternary aeolian deposits called bless, occupying valleys here, like the valley of Zmertene, and pediments with different generation. And also we can find fluvial processes, forms like terraces also in valleys, and alluvial fans in pediments like Prilet Toujene and here the Halgejmel sector. Furthermore, we can find cultural heritage, which are forms of population adaptation to the geomorphological context. We can find three types of cultural heritage, like architecture, like cave dwellings, fortresses, and traditional oil mills, etc. And you can find ancestral hydro-agricultural techniques of Jessur to store rainwater during rainy periods. And finally, it's the military heritage, like trenches here, anti-crafts guns positions, because this cuesta used to be part of the defensive line of Merv inherited from the Second World War. So the geosat inventory, the used methods, the method is the University of Lausanne method. It's based on two criteria, rareness and representativeness, to select potential geosites, and their assessment their assessment is used by an assessment card, like you can see here. It is mainly based on two sections, which is central value based on 4 sub-criteria: integrity, representativeness, rareness, and paleogeographic interest. And their additional values are ecological value, aesthetic, and cultural value. We can see also the use and management characteristics like protection and their promotion. This inventory is composed by 12 geosites with 4 categories. As you can see here, the main interest of each geosite. These geosites show different central values mapped by circles with proportional diameters to each value, and then the additional values which are mapped by using pictograms that show high or very high value. So as you can see, this map reflects high cultural context depending on each geosite cultural components. However, few are the geosites that show ecological interest, which are 4 geosites: Malab, Zmertene, Kathan Sura, and Qarat. So to valorize this inventory, first of all, we should read this definition of geotourism, which is a form of natural area tourism that specifically focuses on geology and landscape, and it promotes tourism to geosites and the conservation of geodiversity and an understanding of earth sciences through appreciation and learning. Geotourism mapping method used in this research is the UNIL-CGMET method based on geomorphological characteristics. Its principles are to select and simplify geological and geomorphological information from the geomorphological map, and then to insert touristic information existing in the area, and this map should be adapted to non-scientific public. So this is the final geotouristical map based on geomorphological characteristics. Here are the geomorphological characteristics simplified from the previous geomorphological map, and here we added the touristic informations. We can find natural heritage, which are the geosites of the inventory, and then the cultural heritage. You can find the prehistoric site, architecture, religion, the marble, and economy like a traditional oil mill, and the military cultural heritage. We can also
2 minutes.
Okay. We can find also protection and valorization by the local post of protected area of Zmertene here, and the other means of the equipment like transportation and sport and leisure. So to conclude, the study area shows rich and natural and cultural heritage with high geotouristic potentials that need to be protected and valorized. Using this method, the UNIL method has showed the importance of different geosites and their specificities, and it's important to diversify the means of promoting of this geoheritage in this area. Thank you so much.
Hello everyone, nice to meet you all. I am Noura Fayad, teaching assistant at the Manhoor University and a master's degree student at Primorska University, Koper, Slovenia. My research is about Paleokarst geomorphology of Qarat Umm Al-Saghir, Western Desert, Egypt. This is a new area and this is the first research on it, and no one before written about this area. So, the introduction. Umm Al-Saghir and the wider areas of formation and evolution of karst is significantly influenced by the different carbonate rock. beds which have been cut through by wadis, occurring in various sizes. The small wadis joins the bigger one in the triantic patterns. Occasionally, when small wadis drain into the larger one from the flank, creating steep rock jumps over which water follows. The rock layers display different resistance to weathering and have been shaped by different processes, giving rise to the distinctive shape of the rocky perimeter of wadis and the occurrence of small and bigger rock soil tears and stone pillars with anki rock relief and lead to a number of caves along the bedding plains. The location, Umm Al-Saghir is a small isolated area. It's located on the western desert of Egypt, south of Marsa Matruh city, for about 198 kilometers, west of Qatar depression for about 38 kilometers, north of Siwa depression 120 kilometers. It's connected to an asphalted by route approximately 100 kilometers long in an area called Bir Nes, located in the route of Marsa Matruh and the Siwa. Here in the map, we can see this is the station, and this is the area, and we took 8 hours from Alexandria to reach this area. And we can see here, this is the Umm Al-Saghir area, and this is the location Egypt. We can imagine now the place. As we say before, Umm Al-Saghir is an isolated area, so the population on it is 725. And the number of the people is still stable until now, because they say that if a new baby come, one of the older men died. So the number is still stable. And the people in this area are Berbers. So they speak the Amazigh language. And the older men and the women also didn't speak Arabic language. They only speak Amazigh language. And the youth in this area translate to the older from Arabic to Amazigh language to understand the people. In the beginning, the people in this village built a fort to protect them from the thieves and the enemy. In the very big top, nearly a mountain. So after that, this fort destroyed by water and wind and rain, so they come down and start growing dates and olives. An archaeological site called the Oasis was constructed using karshif. Karshif is a material with salat and silt. The Oasis has also a number of anki features, including zinc, high salinity, spring, and that have been around since the Roman era. And they have a very hot spring. His name is Caviar, and the temperature reach on it to 70 degrees Celsius. And this is the picture for the fort, what I speak about it before, but now it's destroyed. The objectives. The study aims to identify the Paleokarst formation of the study area and its morphological characteristics, including both small and genetic formation, as well as studying the role of karst erosion plays in founding this formation, and define its geomorphic factors, process, and construction its geomorphological map, with a focus on the Paleokarst feature remaining from the quaternary Paleo-rainy climate and the contemporary ones under the condition of the current drought. The methods we use in this research: geomorphic analysis of the topographic maps and satellite image, and also geomorphic field surveying and mapping. And this is photo we use local station, and in this day we made 12 profiles by it. And also we used field measurement of karst geomorphology features. The setting. The main geological lithology of the study are composed of two geological formation. The first one is Marmarica. It's mostly made up of alterations, limestone and toolstone, the deposition occurring in tropical shallow maritime environment. And the second one is Mogra. Mogra formation, it's lays beneath the Marmarica formation and the overlies the middle Miocene Muqattam formation. In this geological map, we can see here, this yellow is Mogra formation, and it is made in lower Miocene. And this is one is Marmarica formation, is middle Miocene, and this is Sabica from deposits, and this is gold. And this is profile for Marmarica and the Mogra formation in the route between Umm Al-Saghir area and Siwa. Geomorphology, many ancient and current geomorphological factors and processes come together in the formation of the north edge of Umm Al-Saghir depression, and that the fine geomorphological forms such as peaks, grooves, creeps, and the rock fall are the result of these factors over a long time, and the dissolution process and the carbon contact in the limestone rock has an important impact on the decomposition of its rocks, and this is decline. And this is the effects of the joint of mechanical weathering of the surface of Miocene plateau in the north of the area. The result is karst feature. Now we will speak about some of karst feature, not about all in the area. We will speak about some of them. The first one is karst hills. Hills is limited heights remaining from the ancient solution action and affected by wind erosion under the current drought condition, including the major mesa which the ancient Al-Saghir village was built over it, and some of solution caves appear on its slopes. Rocky surfaces are restricted mostly to the south of low hillocks and plateau. It's covered by rock fragment weathering mostly limestone. And this is the residual caves, hills, and the ancient Al-Saghir area built of limestone mesa. And in this area, the people use the cave to protect themselves, to protect them from, to protect the food from enemies and insects. Solution, depression, and lakes. The Miocene plateau occupies the north part of natural lakes and stretches in a west-east direction, and it's characterized by undulating topography. It's composed mostly of limestone belonging to Middle Eocene and the Middle Miocene also. It's covered with gravel sheets belonging to the Quaternary period. They exhibit an semicircular to longitudinal shape surrounded by minor pitted scraps of limestone. As this is one of solution depression. Karst valleys generally drainage lines of the complex granitic type are eroded from Miocene plateau towards the depression and natural lakes, while the most remarked line towards Al-Saghir lakes, the main trend of drainage length are northwest, northeast, and east-west that are controlled by the general trend of front and join the study area. This is one of the valley in the study area. Eroded caves. The eroded caves are ancient caves affected of recent erosion factors that have caused the lowering of debris or the section of the karst surface to collapse, split, or be uncovered. Some eroded caves are recognized in the study area, composed of Miocene limestone, but destroyed under the current aridity condition. And we found that most of the caves in this area are uncovered. Because the roof of it is destroyed because the wind is very, big. And this is eroded caves as a result of mechanical weathering of wind absorption. The conclusion, The study of satellite image and the field study showed that the area of Al-Saghir is spread with some forms of ancient karst, especially karst caves, which arose as a result of presence of karst of rocky joints with the effect of ancient dissolution action. But most of them was destroyed by weathering and erosion factors due to the condition of current dry climate. The remaining hills are also separated by the dry valleys and sometimes plains, and they arose in the carbonate rocks that belong to Miocene and resemble karst hills since the late Miocene. A model has been developed that reflected its evolution as a result of ancient karst process. I finished now. I hope my research is clear and I am ready now for any question.
My name is Thandeka Ndlela, and I'm going to be links between hydrology and vegetation zonation at Malolotja peatland, which occurs in Eswatini. Okay, so peatlands, they are wetlands, but the distinction is that they have at least 30% in dry organic matter, and they have a depth of about, the organic matter is supposed to have a depth of about 30 centimeters. So even though they are characterized mostly by their high organic content, their ability to retain water and therefore their hydrological properties control their So peatland plant communities also vary spatially with the type of climate, the soil, and in particular, the characteristics of the water regime. And this includes like the frequency of inundation, how long the water stays there, and how deep the water table is. So those pictures are just, they show on the right side, you can see a core of peat that was taken from Malolotja, and in that bottom picture is a picture of. Okay, so the peat occurs in northwestern Eswatini. If you look at the map that's on the right-hand side, that area that is nature reserve is. So the peatland itself that is our peatland. There's a team that contains peat that complex and blue color on the hand side. And today, 0.5 and 6 meters, and it covers about 20 hectares in total extent. So we created a transit and we named our monitoring points from A to K. We also installed the rain gauge, as you can see there. The elevation going through the transit ranges from 1,410 to 1,435 meters. We have 10 total, and they are located between 5 and 145 meters apart. And we came up with in our head by the objectives of the project, as well as the size of the study area, and of course things like finances and so on and so forth. To monitor the hydrology, we used wells and piezometers. So monitoring wells are slotted throughout the entire lens. If you can see that drawing there, you can see that in the center there's a monitoring well, and it's allowing for us to the water table, and the piezometer is only slotted in 20s. And on the left-hand side are pictures of actual wells and piezometers as seen in the field. So we had 10 and 18 piezometers in total, and we monitored water level as well as precipitation every week for 13 months. So to describe the vegetation, we described different plant communities present in the an indication of the inundation patterns. The brown blanket approach to describe the vegetation, and we had 2 by 2 meter sample using certified modeling. And then this slide is included how the slope varies across the transect there. So if you see it happens to be like the highest point of the peatland, and the slope decrease as you move towards the south, because A is like the northern part, and as you move towards K, that's the south. So the slope slowly decreases as you move from A to K. Okay, so the periphery, actually that highest point that I mentioned in the previous slide, point A, and then as you move towards the end, if you take your move them towards the end, the H and K, those points found that they had deep water table as compared to the points here that were somewhat in the center. These points had a shallower water table. We also calculated the percentage of the time where the water level was and we found that for these points that are shown in blue, that had what was throughout the monitoring period, and then for these points here, water was found in the root zone, regardless of the amount. Before, we still didn't pick up the points that are located on the periphery. And in contrast, the table, even when we had. Okay, so I was saying that I included the slide because I wanted to show like the profiles that we took and where the water table is. And here you can see that the water table is very high. The water table is this blue line that you can see here. So towards like the center of the peatland, the water table is very high, and that's where you can see, especially at point F, where you get like the deepest peat that we're able to get. And then we also tried to understand the nature of the water flow, whether water was moving downwards or upwards. And I have 2 examples here, 2 points B and F. So at point B, we noticed that the deepest piezometer, which if you can look at that graph there, that's on top, point B, the highest water levels were observed from the deepest piezometer, which is shown by the red color. And this is a sign that a groundwater sweep exists at this point. And at point F, we also had 3 piezometers, but in contrast, the highest water levels at point F were observed from the well, followed by the shallowest piezometer, which is a sign that water is moving downwards at that point. And then we also described the vegetation. And so this slide basically shows that at point A, it's mostly characterized by grasses, mainly those 2 grasses that you can see there. And then as you move towards point C, B, C, and E, you start to get some sedges, although some grasses still exist there. And then there's this shrub that exists here. And if you look at historical images, you can see that the shrub is slowly moving inwards into the peatland. So it's encroaching into the peatland, decreasing the grasses and sedges. And then as you move towards point F and G, you can see more grasses and sedges. And if you recall in that previous slide that I just showed, that's where like the highest water table was. So that's the shallowest part, and that That section is characterized by the grasses and sedges mostly. And then as you move towards the end, towards H through to K, that's where you get the deeper water table again, and that area is mostly characterized by the shrub. So there's also seepage from the slope, mostly shown by those green arrows that you can see there. So the conclusion here is that this peatland, the hydrology is not only maintained by rainfall, but also seepage from the slope, and also the stream also contributes to the hydrology of that site. And then this slide I wanted to show again, just to give another picture of like the vegetation when compared to like the water table. So at this point between 0.01 and A, because I made additional calls, I not only called at our monitoring points, but I made additional calls. So at that point there, that first section, oh, I don't know what happened. So that first section there is the one that's characterized by mostly the grasses. And as you move towards B all the way to G, that's where you find mostly the sedges. And then towards the end here, that's where you get most of the shrub. And you can see that the water table decreases when you move from H through to K. So the main takeaways here that the important sources of water, just like I've mentioned, that influence the hydrology of the peatland, including seepage from the adjacent slope, as I've shown in the images that I showed earlier. And then groundwater is also an important contributor, because if you remember, I mentioned that at one point, especially point B, that's where we found the highest water level in the deepest piezometer, meaning water is moving upwards, and that there's a groundwater seep there. And also because the water table is maintained by the groundwater during water table maintained of rainfall, and also because high heads occurred in deepest piezometers as well as head differentials that existed between the piezometers and adjacent wells, we can also say that groundwater influences the site. And you also saw some episodes of downwelling and upwelling, which is also a sign of groundwater there. Another takeaway is that the deeper water tables are associated with mostly shrubs and some grasses. But the shallower water tables are mostly associated with like the sedges and the grasses. So it's possible to estimate the water table of wetlands and peatlands by describing the vegetation, which means now if there's no finances to have another transect, just by describing the vegetation, you could be able to try and estimate what the water table of that area is. And that brings me to the end of my presentation. I'm so sorry for all the problems, but I'm thankful to have made it to the end. Thank you so much.
Merci de m'avoir donné l'opportunité de partager mes travaux de recherche avec les collègues géomorphologues. En fait, le travail que je vais présenter porte sur la cartographie des zones inondables sur la langue de Barbarie, induite par la houle centennale dans un contexte de changement climatique à l'échéance 2100. Le plan que je propose se présente ainsi: contexte problématique, l'objectif de la recherche, cadre géographique de l'espace à l'étude, les données et méthodes, les résultats de discussion et conclusions, ainsi que les perspectives d'études. Voilà, aujourd'hui, face à l'élévation du niveau de la mer induit par les changements climatiques, l'occurrence des phénomènes extrêmes météo marins, risque d'engendrer des submersions de plus en plus impactantes sur les espaces côtiers. Et selon le GIGC, une élévation du niveau de la mer de 0,5 m provoquerait une intensification de la fréquence des submersions marines de 10 à 100 fois. Cette intensification probable des tempêtes combinée à une forte urbanisation des côtes surtout basses expose davantage les populations aux risques côtiers, notamment les risques de submersion marine. Et de fait, entre 1970 et 2010, la population mondiale exposée au risque de submersion marine a doublé pour atteindre 270 millions de personnes. Et puisque les côtes ne sont vu la diversité morphologique et topographique des côtes, les littoraux ne sont pas exposés de la même manière. Les côtes basses, surtout sableuses, sont les plus exposées aux submersions marines, du fait de leur topographie basse et leur faciès sableux, et leur faciès également sableux. Ces submersions sont des événements brutaux qui peuvent entraîner des conséquences mélodramatiques sur le plan social, mais également sur le plan morphogénique, avec des érosions assez intenses, des dommages impactant les enjeux côtiers. Bon, ces phénomènes n'échappent pas, le littoral saint-louisien n'échappe pas à ces phénomènes. C'est un littoral qui présente des caractéristiques géomorphologiques, géologiques et humaines particulières qui est soumis à ce contexte. Dans s'établissant sur un faciès sableux. C'est un faciès sableux qui est une roche vraiment sensible à l'érosion. Cet espace présente les caractéristiques d'un espace côtier à risque dans la mesure où de nombreux événements extrêmes ont été observés, comme celui de 2017 et de février 2018, provoquant le déplacement de 100 personnes, mais également la destruction de 100 maisons et le déplacement de 2600 personnes. C'est dans ce contexte que se pose la problématique de la cartographie des espaces inondables à Saint-Louis, induite par la houle centennale à en 2100. Bon, les phénomènes de submersion marine sont souvent confondus avec les phénomènes de tsunami, mais il y a une différence. Les submersions marines sont des inondations côtières temporaires induites par la mer lors de conditions météorologiques défavorables. Et de nombreux mécanismes interviennent pour générer ces submersions parce que quand il y a une baisse de la pression atmosphérique dans les zones de basse pression, ça engendre souvent des vents de forte intensité, mais également une élévation du niveau de la mer. Et selon la règle du baromètre inverse, une élévation du niveau de la mer, une chute de la pression atmosphérique de 1 hectopascal correspond à une élévation du niveau de la mer de 1 cm. Et de ce fait, la submersion se manifeste sur la côte à travers deux phénomènes, c'est-à-dire le phénomène de ce type de vagues lié au déferlement des vagues sur la côte, mais également le run-up, qui est l'altitude ou bien la distance maximale atteinte par les vagues après le déferlement sur les plages, suite au phénomène du jugeant de flot. Et sur les côtes également, les submersions se manifestent aussi par plusieurs façons, notamment trois. La submersion par franchissement, la submersion par débordement et la submersion également par rupture. Ici, l'image qui se situe à l'extrémité droite montre bien le phénomène de submersion par franchissement. Le choc frontal de rouleau de vagues sur cet ouvrage de protection génère des gerbes d'eau qui vont surpasser ou bien franchir l'ouvrage pour inonder l'arrière-côte. Ça, c'était à Rufisque, une côte, une section du littoral sénégalais qui se situe à l'est-sud-est de la presqu'île du Cap-Vert, notamment de la région de Dakar. Bon, en fait, l'objectif de ce travail, c'est de faire une cartographie des espaces ou bien des postes qui sont submersibles sur la langue de Barbarie, induite par la houle centennale à l'échéance 2100, c'est-à-dire avec une élévation du niveau de la mer, selon les projections des scientifiques relatives à l'élévation du niveau de la mer. Comme objectif spécifique, nous avons essayé également de faire une quantification en termes de pourcentage des espaces qui sont inondés par la houle centennale sur la langue de Barbarie. Bon, pour la langue de Barbarie, se situe au nord du Sénégal. C'est un cordon sable bas, de 120, s'étendant sur 120 à 400 mètres de large, avec une altitude maximale de 7 mètres. pour une longueur totale de 25 à 30 km. Et sur le plan géomorphologique, c'est une côte, comme je l'ai dit tout à l'heure, c'est un cordon littoral sable bas, de faible également altitude. Et sur le plan hydrodynamique, 3 types de houles atteignent les côtes saint-louisiennes, notamment de la Langue de Barbarie, à savoir la houle nord-ouest, la houle sud-ouest, mais également la houle ouest. La houle nord-ouest est observée quasiment toute l'année. Ce sont des houles également de forte énergie qui atteignent tout au long de l'année les côtes saint-louisiennes. Par contre, la houle sud-ouest est observée souvent en période d'hivernage. Ce sont des houles également assez énergétiques qui subissent tout simplement les phénomènes de réfraction dus à la présence des eaux marins sur le plateau continental. Et par contre, les houles ouest sont des houles exceptionnelles qui sont observées souvent à partir du mois d'octobre jusqu'au mois de décembre. Et sur le plan également toujours hydrodynamique, c'est une côte microtidale dans la mesure où l'amplitude de variation de la ligne de haute mer et de la basse mer, notamment le marnage, n'excède pas 2 mètres. Comme méthode, nous avons employé une certaine démarche méthodologique, à savoir d'élever des terrains sur les plages, ensuite de faire des calculs de pente sur ces plages, ensuite de calculer le run-up, c'est-à-dire la limite maximale atteinte par les eaux sur les plages en cas de tempête ou bien de submersion marine, notamment avec la houle centennale. Bon, ça c'est une image illustrant la méthode employée pour la collecte des données pour les caractéristiques morphologiques de ces plages. Là, on a couplé les stations de base sur la photo qui se situe à l'extrémité gauche avec la borne géodésique de la DTDC. Et là, sur l'image à droite, c'était moi également pour la collecte des données sur le terrain pour prendre des profils de plage cross-shore qui sont perpendiculaires au trait de côte. Pour les données hydrodynamiques, nous avons utilisé un tableau montrant les différentes fréquences de retour ou bien probabilité de retour des houles, la houle centennale, la houle centennale. Je l'ai coloré en couleur grise. C'est cette valeur qu'on a utilisée pour l'intégrer dans le modèle utilisé pour la quantification du run-up extrême sur les plages de la Langue de Barbarie. Bon, nous avons utilisé, afin d'estimer l'extension maximale du run-up, c'est-à-dire le setup plus le run-up sur ces plages, nous avons utilisé un modèle empirique. C'est le modèle qui a été développé par Ullmann en 1986, mais ce modèle a été modifié par Nielsen et Anslow en 1991 à travers le R de 2% et le R max. Le R de 2%, c'est la valeur maximale, c'est la valeur dépassée par 2% des plus hauts jets de rive qui se traduit par une constante sans dimension 0,92 fois la hauteur significative des vagues, également par le nombre d'Iribaran. Et le nombre d'Iribaran se calcule à travers la pente de la plage tangente de B sur HO, LO, c'est-à-dire la hauteur significative. LO, c'est la longueur d'onde à la puissance 1,5, c'est-à-dire 0,5. Ce modèle nécessite deux paramètres d'entrée, à savoir les paramètres hydrodynamiques, c'est-à-dire les caractéristiques de la houle, mais également les paramètres morphologiques, notamment les caractéristiques morphologiques de la plage, en l'occurrence la pente de la plage. Puisque le modèle nécessite l'entrée de paramètres morphologiques, à savoir la pente de la plage, selon Cariolet, il a suggéré que l'utilisation de ce modèle nécessite l'intégration de la pente de la plage qui se situe entre la pleine mer de Vive-Eau et la basse mer de Vive-Eau. Nous avons utilisé les données marégraphiques des tables de marédiction pour calculer la hauteur, les références hydrodynamiques, notamment la pleine mer de Vive-Eau à Saint-Louis, et ça, on a une valeur de 0,83 mètres. Et la pleine mer de Vive-Eau, c'est la moyenne des hautes mers de Vive-Eau sur échéance temporelle de 19 années. De même également pour la basse mer de Vive-Eau, c'est la moyenne des basses mers de Vive-Eau qui sont observées deux fois dans le mois en période de pleine et de nouvelle lune où on a de forts coefficients de marée et sur une séquence temporelle de 19 années et la valeur c'est moins 0,49 mètres. À l'absence de données bathymétriques, ce qui est suggéré, c'est d'utiliser la pente, comme je l'ai dit tout à l'heure, la pente qui se situe entre la pleine mer de Vive-Eau et la basse mer de Vive-Eau. Et cette pente, comme vous le voyez sur la figure, se situe sur la partie intratidale de la côte concernée, parce qu'on n'a pas de données bathymétriques de cette zone. Et la pente de cette plage a été calculée la formule suivante, delta Y sur delta X. Et delta Y, c'est l'altitude, c'est le dénivelé entre l'altitude du point le plus proche de la valeur de la pleine mer de vive eau, qui est 0,83 mètres, et l'altitude également, c'est la différence d'altitude l'altitude du point le plus proche de la pleine mer de vive eau et l'altitude également du point le plus proche de la basse mer de vive eau, qui est moins 0,49 mètres. Et delta X, c'est la distance entre l'altitude du point le plus proche de la basse mer de vive eau, et l'altitude également du point le plus proche de la pleine mer de vive eau. Bon, après cette modélisation, nous avons également essayé de faire une cartographie des parties qui sont inondables ou bien susceptibles d'être inondées par la houle centennale au niveau de la langue de Barbarie. D'abord, nous avons fait une modélisation en utilisant le modèle de Holman et Nielsen, utilisé également au modèle numérique d'altitude de Pléiade d'une résolution de 2 mètres qui est submétrique. Également, faire une quantification des surfaces qui sont inondables en termes de pourcentage et d'identifier tous les enjeux qui sont susceptibles d'être impactés par une inondation générée par la houle centennale à échéance 2100. Et c'est cette méthode qu'on a employée pour faire une cartographie des zones qui sont potentiellement submersibles au niveau de la langue de Barbarie. Bon, en fait, ce tableau montre les sorties du modèle, c'est-à-dire après la modélisation, le modèle nous donne l'altitude maximale atteinte par les vagues sur la côte induite par la houle centennale à essence 2100. Pour le Rmax plus niveau de la mer, c'est-à-dire 0,77 mètres. Sur la partie Gendar, puisque la langue de Barbarie est constituée par 3 entités, par 3 quartiers, c'est-à-dire le quartier de Gendar, le quartier de Ndartout et le quartier de Gokumbat. On voit ici qu'il y a une distribution spatiale inégale des inondations, d'autant plus qu'ici, à Gendar, on a une valeur de 4,71 mètres, à Ndartout, 3,13 et à Gokumbat, 3,04 mètres. Les niveaux d'eau extrêmes atteints sur les 2 quartiers Ndartout et Gokumbat sont sensiblement les mêmes. Et cette différence spatiale peut être expliquée par les caractéristiques morphologiques de ces plages. L'estimation en termes de pourcentage des surfaces qui sont susceptibles d'être inondées par la houle centennale à l'échéance 2100. On voit qu'ici, à Gendar, 88% du quartier Gendar serait submergé par la houle centennale. À Ndartout, 68% de l'espace serait également affecté par les inondations côtières. Et à Gokumbat également, nous avons que 69% également de l'espace ou bien de ces quartiers serait également inondé par les eaux marines. On a fait, pour spécialiser également le risque, nous avons fait une cartographie pour montrer dans chaque quartier les enjeux qui sont sensiblement ou bien plutôt qui sont susceptibles d'être affectés par la houle centennale. Ici, on voit au niveau du quartier de Gokumbat, 68% de l'espace serait submergé. Et les collèges, les écoles, les mosquées, les centres de santé également seront sous les eaux. En ce qui concerne le site d'Ndartout aussi, 69% de l'espace serait submergé par la houle centennale à l'échéance 2100. Le marché, les mosquées également, le centre de santé et certaines écoles qui se trouvent plutôt dans ce quartier aussi seront sous les eaux. Et ce qui est coloré en bleu, c'est l'extension spatiale de l'onde de submersion dans ces quartiers. Le quartier de Gendar, c'est le quartier le plus exposé, le plus vulnérable, dans la mesure où de nombreux enjeux également seront impactés et que 88% du quartier de Gendar serait submergé par la houle centennale. Et en ce sens que c'est ce qui provoquerait aussi des impacts mélodramatique sur la vie socio-économique en affectant également les enjeux côtiers tels que les cimetières, les enjeux culturels aussi, tels que également les activités socio-économiques avec la présence, parce que c'est une zone où il y a une forte présence d'hôtels et de résidences aussi touristiques. Les mosquées également seront aussi submergées. Et le quai de pêche également et les écoles aussi qui se trouvent dans ce quartier, et notamment également certains bâtiments des maisons aussi à usage d'habitation seront potentiellement submergés par les eaux induites par la houle centennale. Bon, en guise de conclusion, nous pouvons retenir certains éléments que la cartographie des ondes qui sont submersibles, la langue de Barbarie, et cette portion du littoral sénégalais est potentiellement vulnérable au risque de submersion marine induite par la houle centennale et que de nombreux enjeux tels qu'économiques, sociaux, culturels, sanitaires seront aussi impactés et que c'est le quartier de Gendal qui est le quartier le plus vulnérable aux submersions marines, d'autant plus que 88% de l'espace gendarien seront sous les eaux à l'essence d'émissions suite à une inondation induite par la houle centennale. Bon, cette étude apporte une information nouvelle sur la représentation spatiale du risque de submersion à Saint-Louis. Et en guise toujours de perspective, nous comptons faire une validation des résultats du modèle sur le terrain, aussi étudier la subsidence, d'autant plus que c'est un cordon sable bas qui est fortement anthropisé. Il serait important également d'étudier la subsidence et de faire une corrélation avec l'élévation du niveau de la mer, toujours pour fournir des informations essentielles pour l'aménagement du territoire, mais également pour protéger ces communautés côtières qui ont fort attachement à cet espace de vie, d'autant plus que de nombreuses activités économiques y sont développées, et de rechercher aussi des solutions innovatrices pour faire face à ces risques côtiers, notamment la submersion marine, mais également de proposer des modèles de protection efficients, également efficaces pour protéger les populations de la langue de Barbarie. Voilà, bon, merci. C'était ça ma présentation. S'il y a des questions.
So, hello everyone. First of all, hello everyone. Nice to meet you all. I am Nesrine Arrak, recently graduated PhD student in geography and risk assessment. I am going to make a presentation about how to detect and monitor the spatio-temporal dynamics of wind accumulations in arid regions. Case study the Jeffara, the southeast of Tunisia. So the work plan is subdivided into 4 parts. The first part is introductory. The second part consists in presenting the methodological approach and conceptual framework. The third part is devoted to presenting the main results, and the fourth part is dedicated to conclusion. Introduction and problematic. General context of the study. The arid regions, including pre-Saharan Tunisia, are characterized by a fragile ecosystem, very vulnerable with very limited resources. This ecosystem is subject to inappropriate human actions and continuous overexploitation in time and space. So the fragility of ecosystems in arid regions, particularly in pre-Saharan Tunisia, is mainly due to unfavorable climatic physical conditions, which are manifested essentially by an irregular precipitation, an active and frequent wind, a fragile soil dominated by sandy loam, and dispersed and spatially reduced steppe vegetation. So this unfavorable climatic and physical conditions associated with inappropriate activities make these regions a favorable ground for the triggering and acceleration of wind dynamics. The anthropic factor is considered the direct and main cause that contributes to the acceleration and intensification of this phenomenon. So in this context, we have chosen the Jeffara region. This region has known since the half of 20th century, the sedentarization of nomadic population. This last one has caused changes in terms of management method and use of space throughout inappropriate practices, like, for example, overgrazing, excessive tillage, clearing of rangeland, and cultivation of steppes. So these inappropriate practices are reinforced by unfavorable climatic conditions. This has consequently led to profound changes in the landscape. These modifications are mainly manifested by the regression of the vegetation cover, which contribute to increase the intensity of the wind dynamics. So the study area is located southeast of pre-Saharan Tunisia. The Jeffara covers an area equivalent to 1,742 square kilometers. The study area is limited at the west by the mountain range of Dahr, at the south by the Fissi River, at the north and the northern plain extended from Gadez to Medenine, at the northeast and the east by coastal Sibkas. So we'll try in this work to achieve the following objectives. In the first place, we will study the spatial variation of land occupations and wind accumulations. Secondly, we will specify the level of coloration between anthropization and the intensification of wind dynamics in the Jeffara. Secondly, methodological and conceptual framework. General methodology. So to precise the relationship between wind activity and anthropic action, we adopted a geochromic approach. This approach consists of studying the spatio-temporal dynamics of land use and wind accumulations. So we seek throughout this approach to follow the evolution and to detect the change in the study area. This flowchart is the technical approach followed in this work. The basic data are radiometry. So we used two types of images, image and sensing tool. The pre-processing step is applied, followed by the processing, the calculation of the radiometric indices and the classifications. The radiometric indices are used at the same time for the classification and in the identification of wind accumulations. So two types of classification are used in this work: the object-oriented classification and the unsupervised classification, to finally get a multi-date land cover maps. This last one will be used as a support to follow the wind dynamics. Setting up of multi-date and multi-sensor for land use maps. So elaboration of a technical approach for realization of land use map. This table presents the two satellite images that are used in this work. These images belong to different sensors, the thematic mapper and the multispectral instrument. The following extract presents an example of the photo interpretation carried out in this work from a very high resolution satellite image and also from GPS surveys taken during field work. The photo interpretation is used in object-oriented classification. So the choice of the most adequate indices for detection the wind accumulation zones. These three indices are already used in the radiometric classification. This indices has favored the identification of the zone of eolene deposit in arid regions. Brightness index, color index, and soil adjusted vegetation index are combined into a single colored composition to highlight the wind accumulations area. The main results. So the main results will begin by the spatial the detection of land use cover. So the following two maps are land cover maps from the year 1985 and 2018. These two maps cover an extended period of 33 years. So we can clearly evolution of landscape in the Jeffara. This evolution is mainly manifested by the increase of the area occupied by cropping, in particular by arboriculture. The following flowchart illustrates statistically the spatio-temporal variation of the three types of land cover during the study area. The two flowcharts present separately the cropping zones and the range land. We can see that the crop area has now since 1985 a spatio-temporal progression that is at the same time rapid and continuous. The occupied area has increased from 15.6% in 85 to 34.7% in 2018. On the other hand, the area occupied by rangelands has now a spatial regression in terms of the area occupied. This last one goes from 80% in 85 to 59.8% in 2018. So now a change detection of wind accumulation. So the following image is a composite image of three radiometric indices for 1985. We note that the wind accumulations presented in yellow color are located essentially in the plain, particularly in the central plain and the low plain. The landscape is characterized by a natural aspect. It is dominated by rangelands. In 2018, the landscape of the Jeffara becomes more and more anthropized. The wind accumulations are always located in the plain, but they are in the low plain. In the high plain, on considerable regression of wind accumulation zones is noticed, while the progression of arboriculture in the low plain was accompanied in parallel by a spatial extension of the eolian deposit zones. So the following two extracts present the spatial variation of wind accumulations in the low plain between 1985 and 2018. The superposition of the arboriculture layer with the wind accumulation zones clearly shows the strong correlation between the extension of the zone occupied by arboriculture and the activation of the wind dynamics. The olive trees has now a spatial progression often correspond to wind accumulation zones. This correlation is noted essentially in the low plain toward the coastal sectors. The study of the spatio-temporal dynamics of land use and the monitoring of wind dynamics lead us to conclude that there is a strong correlation between the two dynamics. The progression in cropping areas has often accompanied by very intense pressure on natural environment. This pressure, which manifested itself in inappropriate and repetitive practices, is considered to be the main factor in the acceleration of wind dynamics. Conclusion. So, in conclusion, we can confirm that based on remote sensing, we managed to achieve our main objective of the study. The reliability of remote sensing in studying change detection and monitoring of arid environments is demonstrated during this work. We can say that this work has allowed to develop a method for mapping land cover based on the combination of spectral bands with derived bands, and also detect wind accumulation zones based on variable radiometric indices and then monitor their evolution over time. So the diachronic approach adopted in this work is considered to be a rapid, inexpensive, and efficient way of assessing and monitoring arid environments. The combination of the three radiometric indices can be considered as a simple and relevant tool to detect and monitor the dynamics of wind accumulations. The land cover maps can be as a decision support tool to combat desertification. Thanks a lot for your attention.
Good morning, everyone. I am Ayabonga Kangatele, and I'm going to present today about life next to a peatland. And this is a case study of the Malolotja peatland in the northwest province of South Africa. So a brief introduction and background. Peatlands provide a wide array of ecosystem services, which range from biodiversity, water retention and purification, as well as provide a few recreational activities, which make them highly valuable ecosystems. In the Northwest Province, according to the Aridity Index, it is classified as semi-arid. Therefore, wetlands are very valuable in that part of the country. And for many areas, wetlands act as a main attraction for resorts and gated communities, as well as nature reserves. Such is the case with the Malolotja Private Park. And this is a picture from the peatland in its pristine condition. You can see a boat launching platform that's just in the middle there as one of the recreational activities that were taking place in the private park. So what the Malolotja peatland is along the Malolotja River, which originates from the Malolotja Oog, an artesian spring in a karst environment. The Malolotja private park is predominantly housing homeowners that are mostly retired people who use their properties as holiday destinations, just to get away from the city. And it is circled there in yellow. And yes, that gray image there is what was once that beautiful image you saw in the previous slide. So the methods carried out to do the study was using online questionnaires which were drafted in English and Afrikaans and uploaded using Google Forms. A PDF document was also sent via email to the residents of the Malolotja Private Park. And a total of 59 questionnaires were sent out. The responses received were 17, and we also conducted one oral interview with someone who was in the Malolotja Private Park for about 17 years, and they witnessed the degradation in the wetland as well as the consequent fire that occurred in that peatland. So we started with what benefits the community received from residing next to a peatland. And many of the respondents indicated that what attracted them there was the beautiful scenery, as there was all kinds of birds and other wetland organisms around that peatland. And many plant enthusiasts were there because there were many different plants around the peatland. So many homeowners just wanted to buy properties because there were those special trees that only grow in that area due to the presence of the wetland. There were also various recreational activities that could take place in the peatland, such as the canoeing and rowing, amongst others. So the peatland presence made the area ideal for holiday homes and provided a beautiful atmosphere with rich biodiversity and a wide range of recreational activities, especially for people who just wanted to escape the city life and just enjoy nature. So because of all these benefits, the property values in the Malolotja Private Park were very high. So the changes that took place within the wetland before it severely degraded was that the water level started decreasing. The beauty and wildlife was also gone, and the boreholes around the wetlands were also decreasing in water levels. And before people knew it, what was once a wetland became a dry land. So the losses experienced, the most obvious was the drying out, which limited the amount of recreational activities that could take place. There was also a decline in biodiversity through migration, with some other species dying because of the dryness. So the fish couldn't migrate and they died. There was a loss of sense of place for many of the residents because of this degradation of the wetland. And there was peat desiccation because of the high organic matter content of the peat. It dried out, and because of the drying out, it was very susceptible to fires, and a wildfire reached the peatland and it caught on fire. So because of the fire, there was a lingering smoke and smell that lasted for about 6 months after the fire. And some people who were taking walks around the wetland in the early mornings also sustained physical injury because they could not see that the peatland was burning, as it was a subsurface fire that occurred. There was a decline in property values because of the lingering smell and the smoke that was around, which was the last straw for some of the residents, and as some of them decided to sell their properties and move elsewhere. And this was a picture taken in 2016 when the peatland caught on fire and it burned for about 3 months. So after that, you would think that all hope is lost, but because of the good rains of 2022, there was an overflow in a weir that is located upstream of the wetland, which led to more water flowing towards the peatland. And this gave a glimmer of hope to the people residing adjacent to the wetland that the system will return to its former glory. And we can see some of the residents starting to renovate their homes because what once attracted them to this area is coming back. And a few of the residents wasted no time enjoying the re-established water flow in the system, as can be seen in this image of one resident rowing his boat in the now wet again peatland. This is a picture that was taken in August 2022, just after the big rains, and water levels of at least 1.5 meters have been re-established in the system, and we are hoping and working towards maintaining that flow. With that said, thank you for your time.
D'accord, donc toutes mes excuses pour le retard. Voilà, donc je me présente. Voilà, je suis Dr Semo Abi et je peux présenter mon thème, c'est différents micro-visages morphologiques.
The voice is not clear.
C'est bon, je peux aller?
Oui, allons-y. Go ahead, please.
Je disais que le thème dont je présente, c'est différents visages morphologiques d'un profil cross-shore sur plage microtidale, le cas des plages donc, du sud-est de la Côte d'Ivoire. Donc, je suis du laboratoire de physique et géologie marine, département environnement, du centre de recherche océanologique. Alors, le plan, donc, c'est, on va une introduction en 1. En 2, on aura donc les méthodes de travail. 3, les résultats. Et en 4, les conclusions. Et donc, en introduction, dans le contexte, nous pouvons dire que le suivi de la morphologie littorale est fait par des levées de profil topographique de plage. Et ce suivi est fait à une échelle personnelle. Et au centre de recherche océanologique d'Abidjan, ce suivi est fait de façon mensuelle. Les morphologies obtenues sont superposées et renseignent sur la dynamique sédimentaire littorale. Cependant, deux états des mêmes profils superposés peuvent coïncider. Alors, cette figure qui est en bas, donc là, figure 1, nous montrons que voici des profils qui ont été pris à des dates différentes. Mais quand on les superpose sur un même graphe, ces profils viennent à coïncider. Alors, c'est quoi la problématique dans ce cas-là? Alors, nous nous demandons, est-ce que la coïncidence d'états pris à des dates différentes des mêmes profils traduisent-elles une absence de mouvement sédimentaire? Et donc, l'objectif principal poursuivi dans ce travail, c'est de comprendre le mécanisme de construction morphologique de la plage depuis le cycle de marée et présenter les différents visages morphologiques qui en découlent sous l'effet de la hauteur significative de houle et de la marée. Alors, quelles sont les méthodes utilisées? Donc, nous nous sommes appuyés sur le suivi altimétrique de l'estrance submergée. Donc, ce suivi consiste donc à relever la topographie des plages. Je reviens. Donc, nous avons relevé topographiquement le processus, donc, en fait, le processus de lever de plage ne pouvant pas nous permettre de comprendre les processus de construction morphologique journalière. Nous sommes révélés, nous sommes plutôt référés sur le suivi altimétrique. Et donc, ce suivi va nous permettre donc de comprendre donc les différents visages morphologiques dans le cycle de marée. Alors, donc, pour cela, donc, des points ont été matérialisés, et par des tiges de fer, et ces plans sont implantés dans l'estrant tous les 2 mètres. Tous les 2 mètres. Leur hauteur, donc, leur hauteur que j'appelle HP, sont relevés au passage des vagues toutes les 5 minutes pendant 12 heures qui correspondent au cycle de marée en Côte d'Ivoire. Et donc, sur la figure donc, numéro 2, ici, nous montrons donc, voilà un profil de plage que nous avons pris. Et nous avons donc maillonné donc, ce profil par des barres de fer en bleu. Et juste à droite sur la photo, nous montrons un site de suivi altimétrique de l'estran submergé. Alors, nous passons donc à des calculs que nous appelons donc le calcul du remaniement résultant, que j'ai abrégé RR. Et le remaniement résultant est obtenu par la différence des hauteurs consécutives d'un piqué. Et donc, le R est obtenu par la hauteur du piqué à l'instant T moins la hauteur du piqué à l'instant T plus 1. Il renseigne sur les amplitudes de mouvements sédimentaires verticaux toutes les 5 minutes. Nous calculons aussi donc, le remaniement résultant cumulé, RRC. Et le RRC est obtenu par la somme des RR. Et il renseigne sur l'itinéraire morphologique dans le processus de construction de la morphologie de la plage dans le cycle de marée. Et lorsque le RC est positif, il traduit un engraissement. Et lorsqu'il est négatif, il traduit donc une érosion. Et donc, pour ce faire, il faut donc aussi implanter un profil de plage. Et donc, on passe donc à l'implantation d'un profil de plage. Nous avons aussi joindre les données de marée que nous avons pris donc sur le site Choum, donc le site Choum, un site français, et qui va nous permettre donc d'obtenir donc le cycle de la marée au moment de l'expérience qui est ici. Nous avons une phase du flot et nous avons une phase de gisant. Nous avons aussi joint donc les données de houle que nous avons extraites donc sur des données satellitaires sur le programme URA 40, sur donc le lien que j'ai indiqué ici en adresse. Alors, quels sont les résultats que nous avons obtenus? Et donc, lorsque nous avons donc des données de houle qui oscillent entre, qui sont inférieures à 0,5 et un manage qui est aussi inférieur à 0,5 mètres, nous avons donc une morphologie qui se concentre dans le cycle de marée avec une érosion dans la phase de la pleine mer, au flot, au voisin de la pleine mer, et un engraissement au voisin de la basse mer. C'est ce que je traduis ici donc par le rouge. Le rouge, là, j'en sais. Nous avons donc une érosion dans la phase du flot et un engraissement dans la phase du gisant. Et donc, c'est un profil. Ici, donc, nous montrons les profils, les points qui sont plus au ouest. Ce sont les points qui sont moins visités par les vagues et donc qui ne traduisent pas mieux donc, la morphologie de l'estran. Par contre, ici, nous voyons sur cette figure, donc figure 4, effectivement, l'érosion. Quand on regarde en bas ici, nous avons la courbe de marée plus bas. Et donc, dans cette courbe de marée, nous voyons que la pleine mer qui est ici est matérialisée donc par l'érosion. Et lorsque nous sommes à la basse mer, nous avons donc un engraissement de la plage. Alors, quand on regarde de façon synoptique, qu'est-ce qu'on regarde? Lorsqu'on voit donc tous les points ensemble, on se rend compte qu'effectivement, au voisin de la pleine mer, là j'ai entouré en rouge, au voisin de la pleine mer, excusez-moi, au voisin de la pleine mer, nous avons donc une érosion, le profil donc s'érode, aussi sur le profil qui est là que sur le profil donc de droite. Et lorsque nous sommes en basse mer, nous avons donc un engraissement des plages. Lorsque nous changeons donc de conditions de marée et de houle, et que nous avons donc des conditions de marée qui sont comprises entre 0,5 m et 1,5 m, et une hauteur de houle effectivement donc toujours inférieure à 1,5 m, dans ce cas, la morphologie change et nous avons un engraissement au flot, donc au voisin de la pleine mer, et au contraire, nous avons une érosion donc au gisant à la base, au gisant à l'approche donc de la basse mer. Et ce que nous matérialisons ici, sur cette graphe en bas entouré en bleu, nous voyons donc un engraissement. Et donc, le profil continu ici que j'ai découpé en deux sur cette figure. Et donc, nous voyons que lorsque nous sommes à gauche là, tout ce que j'ai encadré en rouge là, c'est la phase donc de l'engraissement de la plage qui se fait donc au gisant. Et la phase donc de l'érosion de la plage qui se fait donc dans la phase du flot. Donc la plage va s'engraisser lorsque nous sommes à l'approche de la pleine mer et elle va s'éroder lorsque nous sommes à l'approche de la basse mer. Et lorsqu'on regarde donc tous les points ensemble, on se rend compte effectivement qu'à l'approche de la basse mer, on a le rouge qui matérialise donc l'érosion. Le rouge, tout le rouge qui matérialise l'érosion. Et donc les plages s'érodent à l'approche de la basse mer. Et là, de l'autre côté, à droite, sur la même diapo, donc matérialisé en bleu, à l'approche de la pleine mer, et on se rend compte que les profils sont dominés donc, par la création des plages. Lorsqu'on veut aussi à changer les conditions de houle et marée encore, et que nous tombons dans des conditions de houle et marée plus grandes, entre 1,5 et 2 mètres, et des marnages encore plus élevés, entre 8,5 mètres et 1 mètre, en ce moment, là, les plages demeurent en érosion. Mais si ces points sont replantés sur les points de voie extra, ce sont les points qui sont touchés par les vagues, dont les vagues ne touchent pas fortement, et donc ces points sont insignifiants, ne peuvent pas matérialiser donc, les visages morphologiques. Mais par contre, si on vient ici, plutôt quand on descend plus bas sur les points qui sont plus au bas extra, on se rend compte que la plage demeure carrément en érosion. Durant tout le cycle de marée, elle demeure en érosion parce que les conditions de houle et de marée ont changé et ont augmenté. Et donc, c'est ce qu'on traduit ici encore sur ces différents points. Une érosion permanente de la plage lorsque les conditions de houle deviennent plus grandes. Ici, donc, quand on regarde de façon synoptique tous les points ensemble, on se rend compte effectivement de cette érosion permanente dans le cas donc, des houles supérieures, compris entre 1 mètre et 2 mètres. Nous sommes ici donc dans le cas de la pleine mer et l'érosion totale. En basse mer également, si l'érosion totale, l'érosion dominée par le rouge matérialise l'érosion. Et sur toutes les figures, donc, on voit l'érosion parce que les conditions de houle ont changé et sont supérieures, sont comprises entre 1,5 et 2 mètres. Alors, qu'est-ce qu'on peut retenir? C'est que nous avons trois visages morphologiques. Donc, on peut dire que la morphologie littorale est la réponse des agents de forçage hydrodynamique dont la houle et la marée sont les principaux éléments qui façonnent les plages. Donc, nous avons trois tendances morphologiques qui se dégagent dans la construction de la morphologie journalière tidale. Donc, une plage peut s'éroder au flot, au vaginage donc, de la pleine mer et s'engraisser au gisant, au vaginage de la basse mer. Et cette tendance morphologique va se réaliser pour un manage modéré inférieur à 0,5 m et une hauteur de houle modérée inférieure à 1,5 m. La plage peut aussi donc s'éroder au gisant, au vaginage de la basse mer et s'engraisser au flot, au vaginage de la pleine mer. Cette tendance se réalise pour un manage compris entre 0,5 m et 1 m et une hauteur de houle qui est inférieure à 1,5 m. Et enfin, une plage peut demeurer en permanence en érosion le long du cycle de marée. Et cette tendance se réalise lorsque le manage est compris entre 0,5 m et 1 m, une hauteur significative de houle qui est compris entre 1,5 m et 2 m. Je vous remercie. Voici ainsi présenté ma présentation.
Bonjour, mesdames et messieurs les participants à la Semaine internationale de géomorphologie. Notre communication porte sur le sujet dynamique morpho-sédimentaire actuel dans la vallée de la rivière Gambara au nord Togo. Elle sera présentée suivant ce plan: contexte, problématique, méthodologie, résultats, discussion et conclusion. La zone d'étude se situe au nord Togo, à cheval sur le plateau de Bombouaka et la plaine de Lotsi, dans le domaine de climat tropical soudanien, où les densités humaines sont assez élevées, supérieures à 150 km². Cette pression démographique élevée se traduit par une forte occupation du sol. Le problème se présente donc dans les termes suivants. En fait, la vallée de la rivière Gambara offre d'énormes potentialités agronomiques, d'où une occupation intense de celle-ci par l'agriculture. En fait, dans le contexte de changement climatique dans le nord Togo, cette vallée-là est l'une où on pratique encore la culture, par exemple, de petits milles. Et on arrive, c'est-à-dire que la saison commence très tôt dans la vallée, et de sorte que là, bien que nous soyons dans une zone de climat soudanien, les paysans arrivent à faire deux saisons, en fait, deux récoltes au cours de la même année. Donc, ce potentiel a fait que la vallée est bien occupée par les activités agricoles. Mais l'écriture vide de la rivière et l'alluvionnement d'une part et la forte mobilité du lit d'autre part mettent à rude épreuve les écosystèmes pluviatiles de cette rivière, occasionnent d'importantes pertes agricoles et entraînent la destruction des ouvrages hydrauliques qui sont réalisés sur cette rivière. C'est cette situation qui a suscité la présente étude. Et la question de recherche a été formulée comme suit. Quel est le bilan morpho-sédimentaire actuel dans la vallée de la Gambara? Et l'objectif visé est de caractériser la dynamique morpho-sédimentaire dans cette vallée. Pour atteindre cet objectif, nous avons adopté une méthodologie comportant la collecte des données sur le terrain, les travaux en laboratoire et les traitements des données collectées. Sur le terrain, les données ont été collectées par levée topométrique au chaînage, au théodolite et au GPS. Une prospection pédologique détaillée a été également faite sur le terrain. De même, nous avons collecté les données climatiques sur le terrain. En laboratoire, donc nous disons que en laboratoire, la mobilité du lit a été étudiée par télédétection. Nous avons effectué également des analyses des échantillons qui ont été prélevés pour caractériser les formations superficielles et traiter les images satellites pour caractériser l'occupation du sol. Le traitement des données collectées a permis d'obtenir les résultats sur la géomorphométrie et la géomorphodynamique du lit. Au plan géomorphométrique, la rivière donc se présente comme ci. Donc, nous avons une largeur de plein bord qui est en moyenne de 17,8 mètres, une longueur d'onde, de 208,8 mètres et une amplitude de méandrage de 422,3 mètres et un indice de sinuosité qui est en moyenne de 1,4 mètres. Sur la morphodynamique, l'étude de la mobilité du lit révèle qu'elle se manifeste sous diverses formes, à savoir le recul de la berge concave et l'avancée de la berge convexe ou la translation. Donc, ceci se produit naturellement au niveau des courbures des méandres, au niveau des tronçons qui sont plus ou moins rectilignes. Nous avons une translation donc, qui résulte du déplacement des deux berges, comme nous l'avons ici, d'accord, une translation donc, du déplacement des deux berges dans le même sens, donc se traduisant par une translation de lit, ou alors un élargissement de lit, comme sur cette portion-là, qui est lié en fait, au recul des deux berges. Donc, dans l'ensemble, le déplacement des berges est assez rapide. Cette image, par exemple, illustre le recul d'une berge au cours d'une même crue. Donc, soit un recul d'environ 5 mètres, se traduisant par le renversement de plusieurs arbres le long du cours d'eau, comme on peut l'observer sur cette image. Ces images également illustrent le déplacement des berges qui conduit à l'exagération de méandres ou à leur recoupement. Sur l'image 1, donc l'ondulation que nous avons ici s'est exagérée pour donner la boucle en A, donc en A2 entre 2016 et 2018. Le méandre donc, de l'image B2 en 2016 que nous voyons ici donc, a évolué pour s'auto-capturer, donc comme on peut le voir ici, donc en 2018. Les résultats donc d'études par topométrie directe au sol révèlent un déplacement donc annuel variant entre 0,1 et 20,5 mètres, soit une moyenne de 3,5 mètres par an. Par contre, la topométrie par télédétection donne des valeurs comprises entre 0,02 mètres et 37 mètres par an, soit une moyenne par cette approche de 1,16 mètres par an. Et bon, pour l'ensemble des deux approches, nous avons obtenu une mobilité moyenne de 1,7 mètres par an. L'analyse des bilans sédimentaires révèle quant à elle un alluvionnement, comme l'illustrent ces photos, donc qui nous montrent un lit ensablé pratiquement jusqu'au ras-bord. On voit que ici le lit est plein de sable, donc jusque pratiquement au ras-bord. Cette image également illustre une défluviation donc corrélative à l'obstruction donc du principal bras, et donc à l'alluvionnement dans la plaine, comme on peut le voir donc au cours d'une crue qui a été forte dans la vallée. Les levées comparées de la côte du fond du lit en différentes sections montrent une tendance à l'exhaussement du fond du lit à un rythme donc moyen variant entre 6 et 28 cm par an, soit une moyenne interannuelle de 16 cm par an. La dynamique morpho-sédimentaire tient directement à deux variables, à savoir le débit liquide et le débit solide. Mais l'inexistence de données sur ces deux variables nous a amené à choisir donc d'analyser les variables de contrôle de celles-ci, à savoir le relief, la pluviométrie, les couvertures pédologiques et l'utilisation des terres. Donc, l'analyse des précipitations montre qu'elle varie en moyenne, le cumul annuel varie en moyenne entre 821 et 1360 mm, avec une moyenne de 1054 mm au cours des 30 dernières années, avec une tendance qui est caractérisée par une baisse de pluviométrie. Et donc, ces caractéristiques pluviométriques, naturellement, ne sont pas favorables à la crise morpho-sédimentaire actuelle. Et le relief avec une pente générale faible, donc une pente à long du cours d'eau, soit sous 4,6%, donc a une influence moyenne. Tandis que les couvertures pédologiques, qui sont dans l'ensemble peu épaisses, est caractérisée par un engorgement très rapide et une érosivité forte, sont des facteurs plutôt favorables à l'érosion des berges, et donc ce qui fait que les berges se déplacent facilement, donc du matériel qui est meuble, qui s'engorge facilement, et donc qui accélère également les processus d'écoulement. Mais le facteur qui a déclenché donc cette crise est plutôt l'utilisation des terres, dont l'évolution a été marquée au cours donc, de ces dernières décennies par une extension rapide des surfaces emblavées qui sont passées de 8,26% en 1970 à environ 83% en 2020. Donc, c'est le principal facteur déclencheur de cette dynamique-là. Donc, la présente étude a permis d'établir une mobilité moyenne des berges de 3,5 mètres par an et 1,7 mètres par an, respectivement par topométrie directe au sol et par télédétection, et un bilan sédimentaire de 0,16 mètres par an. Les travaux réalisés par Campinandia en 2016 ont permis d'obtenir des résultats similaires sur la rivière Oti et ses principaux affluents de rive droite, soit une mobilité moyenne des berges de 1,9 mètres par an. Par contre, Bawa, en 2012, a trouvé un recul annuel plus faible sur la rivière Pelou, soit 0,12 mètres et 0,63 mètres respectivement sur la Pelou et la Jidée. Donc, l'étude de la dynamique morpho-sédimentaire de la Gambara à partir des différentes méthodes a permis de la caractériser. Elle ne se manifeste par l'érosion et l'alluvionnement, dont les effets combinés se traduisent par une forte mobilité des berges et un bilan sédimentaire excédentaire. L'occupation du sol ayant connu un changement profond est le principal facteur déclencheur de cette crise. Aussi, nous pensons que la solution à cette crise morpho-sédimentaire passe par le reboisement donc du bassin versant en général et des berges en particulier. Et la combinaison des systèmes de culture agroforestiers et du reboisement des berges apparaît comme l'une des approches les plus efficaces et durables. Il faudrait pour le reboisement des berges tenir compte de la mobilité de celles-ci et choisir des espèces au système racinaire très développées et ou buissonnantes comme le raffia. Les espèces arborescentes au système racinaire développé comme le rognier pourront également être utilisées. En plus de ces espèces, d'autres espèces locales pourront être plantées pour une restauration rapide de la biodiversité. Nous vous remercions pour votre aimable attention.
My subject about effect of the global digital elevation model on determining the geomorphological stage of dry wadis in major basins east of the Gulf of Suez, Egypt. My presentation contains the introduction, study area, objectives, material and method, results and discussion, and conclusion. The introduction: digital elevation models provide data of the three-dimensional of the Earth's surface and are useful to a wide range of disciplines. Them and its characteristics attributes are important parameters for information extraction or assessment of any process using terrain analysis. Geomorphological process inside a wadi basin affected by erosion factors such as water and wind. The evolution of the erosion in wadis aims at knowing hypsometric integral and determining the geomorphological stage in these wadis. The geomorphological stages are young stage, major stage, and old stage. So, geometric analysis helps to understand various factors that influence the topographical characteristics of a drainage basin. It evaluates data related to water structure at different elevation level within an area. It has been used for different studies in many drainage basins of the world. The studies depended on a global digital elevation model to extract the topographical characteristics which are used to determine the geomorphological stage. Based on the literature review and to fill the study gap, the current study aims to know the effect of global digital elevation models on determining the geomorphological stage of dry wadis. The study area. This is the location map of the study area in Egypt. The study area is located in the east of Gulf of Suez, between Wadi Sadr in the north and Wadi Al-Awak in the south. It has an area of 10,155 square kilometers. Its elevation ranges between 0 meter in the west and 2,250 meters in the southeast. It is scarp bordered from the east, Logma scarp bordered from the southeast. The objectives of my study: the study aims to determine the geomorphological stage in the study area depending on some global digital elevation models of different spatial resolutions, as well as to answer the following questions. Does the geomorphological stage vary in any drainage basin depending on more than one BIM? So, the study depends on topographic maps to determine the geomorphological and topographical characteristics of the study area. It used some digital elevation models to extract the drainage basin characteristics which are SRTM30, SRTM90, NASA, Tandemix, Copernicus 90, Copernicus 30, Aster, AW3D30, and Alus Balsar. This is the table of the digital elevation model that using in the study. This figure displays the methodology of processing and analyzing data by using geographic information system. So the study used ArcGIS 10.5 desktop to process and analyze data, as well as depended on the SPSS program to calculate the Pearson correlation for results. As well as the study depended on Pike and Wilson model to calculate the values of the hypsometric integral of drainage basins. And the study depended on structural classification of the geomorphological stage of basins. This table displays the classification of geomorphological stages. Now, results and discussion, area data of basins. This figure 3 displays the borders of basins depending on all dens. So the area data of basins is important to determine the geomorphological stage in watersheds by using its borders to extract the elevation data. It ranges between 42 square kilometers in Wadi Abu Mangrat and 1,942 square kilometers in Wadi Al-Awad. There are differences between this data due to the difference in depth. Some basins have a large range in their area data, which are Baba and Grundling. The abnormal data is extracted due to the merger process found in some basins located next to Baba and Grundling basins. These mergers process are affected by Aster and Alus Balsar digital elevation models. So the hypsometric integral of basins range between 0.19 in Wadi Al-Awad Menadik stage and 0.51 in Wadi Nikhil Meteor stage. The three table displays hypsometric integral and the geomorphological stage of all basins in the study area. The symbol of HI is hypsometric integral and the symbol of GS is geomorphological stage of in all basins. As well as the relationship between them and geomorphological stages, the relationship between hypsometric integral values of basins is a very high positive correlation depending on all depths. So all basins are located into one geomorphological stage depending on any of these models, except for Wadi Wasit and Wadi Tiba. Wadi Wasit is a measure stage depending on all depths, except for Alus Balsar dam, which merging between Wadi Wasit in mature stage and Abu Mangrat in Medenine stage in one basin. This is the fig, or this fig displays the geomorphological stage and hypsometric integral of basins. This is the mature stage from to, this is the Medenine stage. Wadi Taiba is in the mature stage depending on SRTM30, SRTM90, Tandemix, Copernicus 90, and Alus Balsar. It is in the Medenine stage depending on NASA, Copernicus 30, Aster, and AW3D30. Its hypsometric integral values range between 0.34 and 0.36. These values are different due to structural classification of the geomorphological stage. Conclusion: this study focuses on the relationship between the digital elevation models and on determining the geomorphological stage of some basins east of the Gulf of Suez in Egypt. It uses a new method of processing data to determine this relationship. Overall, all dams create one result from determining the geomorphological stage in any basin. This study recommends using any dam from all dams for determining this index, except for Aster and Alus Balsar digital elevation models, as these models have some errors in extracting the elevation data These errors are created due to the merger process of some basins. Thank you.
Donc, salut chers tous. Je crois que c'est une occasion pour nous d'apprendre à travers ces communications. Et sincère merci à l'Association internationale des géomorphologues, de géomorphologie. Notre présentation porte sur les impacts environnementaux de l'exploitation des héritages géomorphologiques dans le bassin versant de l'Anié, au Togo. Donc, c'est dans la partie centrale du Togo. Le plan de notre présentation s'articule comme suit. On va d'abord présenter la zone d'étude pour permettre aux uns et aux autres de savoir le cadre de notre étude. Après, il y aura la problématique, la démarche méthodologique, les résultats et discussions et enfin une conclusion. Notre zone d'étude s'étend sur 0°43 et 1°18 de latitude est et 7°36, 8°48 nord et couvre une superficie de 4114 km². Au Togo et en particulier dans le bassin versant de l'Anié, les héritages géomorphologiques exploités par les hommes pour leurs besoins courants regroupent les affleurements rocheux, les cuirasses, les altérites, les sables, les graviers et les terrasses alluviales. L'exploitation de ces géoressources s'est accélérée à cause des besoins croissants des populations dont l'activité principale est l'agriculture itinérante sur brûlis avec ses graves conséquences sur le couvert végétal. L'agriculture est associée à l'exploitation des héritages géomorphologiques, devenue la première source de revenus complémentaires des populations locales. Au-delà des revenus substantiels, la mise en valeur intense de ces milieux affecte plusieurs composantes environnementales, ce qui suscite les interrogations suivantes. Quels sont les impacts environnementaux? Quels sont les impacts environnementaux liés à l'exploitation des héritages géomorphologiques dans le bassin versant de l'Anié? Quelles sont les stratégies ou les mesures à prendre pour une gestion durable du bassin versant de l'Anié? De ces questions, nous avions formulé des hypothèses. L'hypothèse 1, donc ici, l'exploitation des héritages géomorphologiques génère d'énormes impacts environnementaux. Des mesures préventives et correctives sont proposées pour une gestion durable du bassin de l'Anié. L'objectif est d'évaluer les impacts environnementaux de l'exploitation des héritages géomorphologiques et de proposer des solutions idoines pour une gestion durable du bassin versant de l'Anié. L'approche méthodologique est la suivante. Nous avions adopté une démarche qui s'articule autour de 4 points. D'abord, une recherche documentaire et qui s'est faite soit par Internet, dans les bibliothèques et dans les services spécialisés. Nous sommes allés sur le terrain où nous avons fait des entretiens semi-directs, ce qui a permis de décrire et analyser les facteurs de vulnérabilité et les éléments vulnérables dans le bassin versant de l'Anié. Au niveau du laboratoire, les images satellitales ont été traitées pour permettre d'avoir une carte de l'occupation des sols et préparer une carte de gestion durable du milieu. Il y a eu un traitement et analyse des données. À travers cette méthodologie, les résultats auxquels nous sommes parvenus se présentent comme suit. Il faut noter que le premier impact environnemental lié à l'exploitation des héritages géomorphologiques reste la destruction du couvert végétal. En effet, quelle que soit l'activité, les végétaux sont systématiquement abattus, puis parfois mis à feu pour libérer l'espace. Ces pratiques contribuent au recul du couvert végétal, comme nous sommes en train d'observer sur ces deux photos. La première photo, ici, à ma droite, c'est un dépôt de bois de chauffe, et à ma droite, il s'agit là des cultures sur brûlis qui dévastent la couverture végétale. Donc, les images, comme nous l'avons dit, à travers les images satellitales, nous sommes parvenus à tirer une carte d'occupation du sol en prenant deux périodes. D'abord, la période de 1999 et la période de 2020. C'est la carte d'occupation du sol ici sur les deux périodes que nous venons de décrire. Donc, on se rend compte, en observant ces cartes, on se rend compte que sur les deux périodes, c'est-à-dire de 1999 à 2000, les agglomérations sont parties de 0,21 en 1999 à 0,81 en 2020. Pendant cette même période, la couverture végétale qui était en 1999 de 29,93% de la superficie a reculé pour devenir 15,79%. Donc, ça a montré combien de fois l'exploitation des héritages géomorphologiques dans le bassin versant de l'Anié dégrade considérablement le couvert végétal. En ce qui concerne les pratiques agricoles, il faut noter que la contribution des activités agricoles dans le processus de la dégradation de l'environnement se situe à plusieurs niveaux. D'abord, l'agriculture sur brûlis met à nu les sols, puis les expose à l'insolation et aux eaux de ruissellement. L'introduction des herbicides dans les pratiques agricoles appauvrit les sols en détruisant les micro-organismes responsables de la formation et fertilisation des sols et aggrave la pollution hydrique. À tout ceci s'ajoute l'installation des transhumants dont les troupeaux dament les sols et les transforment en des surfaces indurées, détruisant ainsi les écosystèmes naturels. Quant à l'exploitation minière, sa responsabilité est diverse. Elle aggrave les actions des eaux de ruissellement. Elle contribue au réajustement morphologique le long de l'Anié. Elle dénature la topographie du milieu. Elles sont source de déséquilibres hydrosédimentaires. Elles détruisent les mémoires du climat. Nous voyons ici, sur cette photo, l'ensemble des quelques clichés qui montrent la dégradation de l'environnement due à l'exploitation minière. La photo la première photo A, ici, nous avons là une niche de décollement due à l'exploitation du gravier. Et la photo B, ici, montre une mare laissée par l'extraction du gravier. Et la photo C, ici, c'est un dénivelé brutal sur le site de l'exploitation du marbre par la société Pomar. Et là, ici, nous avons une carrière de concassage des cuirasses délaissées qui laisse un paysage qui n'est pas du tout bien géomorphologiquement parlant. Face à tous ces impacts environnementaux, les populations locales ne sont pas restées indifférentes. Elles ont adopté quelques stratégies endogènes dont nous allons faire connaissance. Elles commencent par adopter une culture ou bien la pratique des biomes perpendiculairement aux pentes et aux cultures en terrasse par endroits. Elles pratiquent également une politique de reboisement et de l'agroforesterie. Elles pratiquent l'association des cultures, une mise en jachère et paillage du sol à l'aide des résidus des récoltes. Le renforcement et l'information, la sensibilisation et l'éducation par les ONG est observé sur le terrain. Nous avons ici quelques mesures endogènes mises en œuvre par les populations locales. Ici, nous avons une balise qui permet d'alerter face aux crues et pour éviter les inondations. Là, cette balise est complétée ici par une balise graduée, donc avec des couleurs différentes. Lorsque les crues d'eau arrivent déjà au niveau de jaune, donc on alerte les populations qui se retrouvent au bassin inférieur pour prendre les dispositions idoines. Ici, c'est le gravier qui est versé sur une piste pour la rendre praticable après la dégradation. Donc, nous avons proposé un schéma directeur de l'aménagement du bassin versant de l'Anié pour compléter les stratégies endogènes. Notre stratégie proposée prend en compte 6 axes qui se résument sur cette carte ici. Premièrement, nous proposons qu'il faut une création des conditions de mise en valeur agricole des plaines inondables dans le bassin. Et donc, naturellement, on peut faire des retenues d'eau pour faire la riziculture si nécessaire, très nécessaire par endroit. Au-delà de cette mesure, nous proposons la construction des bassins de rétention d'eau dans diverses localités du bassin inférieur pour éviter les inondations. Il faut également des aménagements des carrières délaissées par les exploitations industrielles, c'est-à-dire marbre, latérite et des surfaces de cuirasse. Il faut le développement des géoparcs sur les chaînes des monts Togo et les massifs basiques et ultra-basiques de notre zone d'étude. Et nous avons proposé également la construction ou la réhabilitation des ouvrages de franchissement sur la rivière Anié et ses affluents. Donc, il faut également l'installation de nouveaux luminographes sur Anié et ses affluents pour pouvoir mieux suivre l'évolution des crues et éviter les inondations aux populations. Discussion. Donc, l'exploitation des héritages géomorphologiques entraîne la régression du couvert végétal, l'érosion des versants, la modification de la topographie, la dégradation de la structure des sols, l'inondation dans la basse vallée, la pollution hydrique et celle de l'air par les poussières en saison sèche. Ces impacts environnementaux identifiés sont similaires à ceux de Chenti Nabin 2000, Chenti 2006, Kwame 2005, Kuya 2010, Aliti 2019, Aïvi et Ol 2016. Hors de nos frontières, les études de Mokpa et Ol en 2007 et Diarasuba et Ol 2017 ont aussi montré que l'exploitation des graviers, sable et la production du diamant dégradent le couvert végétal et les sols. Ces activités créent un relief accidenté caractérisé par des trous au diamètre variable, résultat qui corrobore ceux obtenus dans le bassin versant de l'Anié où le marbre est exploité à ciel ouvert. En conclusion, la présente étude a permis de mettre en évidence les impacts environnementaux inhérents à l'exploitation des héritages géomorphologiques. La stratégie de gestion durable formulée se résume en une carte d'aménagement prenant en compte 6 axes. Je vous remercie, chers participants.
I said that I will start my presentation with this question. Why study underground and karst in Tunisia? So underground karst in Tunisia, specifically in the central region, is well known by the presence of many active or inactive caves. However, this cave is always considered as an active and dangerous environment. And then they have been little studied by the geomorphologists. Despite the variety and the importance of their endokarstic deposits, which are considered as a partial archive of castogenesis and speleogenesis. So from this comes the idea of study, which seeks to understand the speleological evolution of phreatic paleokarst of Galkine state, specifically in the Tebaga region in the northern of Tunisia, by focusing on the analysis of the endokarstic deposits and forms in this cave. So the objectives of this study are as follows. First, identify and characterize the spatial arrangement of the endokarstic forms and deposits. Then propose a coherent chronostratigraphic schema of deposits accumulated in the Galkine cave. And after that, specify chronologically the major speleogenesis phases of the cave. Now let's move on to research methodology. So this study is based on...
Sorry,
yes,
sorry to interrupt again, but your slides, we don't see the methodology slide.
What about now?
No.
No. Now? Yeah. Okay. So this study is based on three approaches. The first is the speleological approach, which makes it possible to characterize the endokarstic environment. The second is the cartographic approach, which enables us to produce maps for different parts of the cave based on speleological documents. And the third is analytic approach. In this approach, two types of analysis are used. The first type is uranium-thorium dating of carbonate deposits, in particular Sardiman. This analysis makes it possible to specify the different phases of concussion and to define the chronostratigraphic of deposits inside the cave. The second type is the X-ray diffractogram analysis used for the deuterial fine deposits, and this analysis makes it possible to establish the overall mineralogical characteristics of deposits. So now let's talk about results and findings. I will be summarize the results of this study on three main points. The first point interests in study area characteristic. The second is focused on endokarstic forms and deposits accumulated in the cave. And the third point aims to define chronologically the major speleogenesis phases of the cave based on some deposits and forms, also the process that contribute in this speleogenesis. So I will start by the studied cave characteristics.
Can you
as you
the
see,
slides again, please?
Yes, of course. What about now?
Yeah,
no?
we see the results. You just have to make sure that you move them every time.
Yeah, it worked?
It's in presenter view, but I mean, it's on the correct slide, so that's fine.
Mm-hmm.
We still don't have full screen, but don't worry about the full screen. Just keep moving the slides manually.
Yeah, sorry for that. So I will start by the studied cave characteristics. So our studied cave is a part, as you see in the map in the left, is a part of the Tebaga region in Tunisia. It consists of modest altitude mountains formed le Mont Borsa. In this region, the Galkine cave is formed on the northeast of Chetlo mountain at an altitude of more than 500 meters. So this cave extends 1,130 meters long and 150 meters deep. As you see in the map in the right, it's mainly developed in the IUC limestone rocks. So this cave also consists in two parts or zones. So a confinement zone corresponds to an inclining paleotunnel, which is partially collapsed, and confinement zone consistent of the succession of galleries, These galleries of this part of the cave contain many forms and deposits. So the speleological examination of the endokarstic forms and deposits within the Rakris cave shows two main types. The first one.
Sorry, you're going to have to move the slides again.
So the first type is cave ceiling and walls forms, and the second cave floor deposits. About cave ceiling and walls form, there are diverse in both origin and nature. We distinguish formed origin forms from forms linked to draping and infiltration, black footprints left by bat. Let's start now by the drowning origin forms. So these forms were formed by corrosion process, and in the cave, these forms are varied. We can see different dome or cupolas, like for the cupolas, deep cupolas of wall and micropore, etc. As you see in these pictures.
I have to move
other forms
again because we don't see any pictures. Thanks.
So other forms such as microstalactites, like you see it in the picture in the left and the right, sorry, and the eccentrics forms in the picture and in the left. These forms were formed by draping and fractured limestone. Is it okay? In addition to these forms, we have also a dark trace of hydroxyapatite, which formed when urine and guano reacted with the limestone rock. This dark trace covered much of the cave ceiling.
We don't see that slide.
You don't see the footprints left by bat, no?
On the 12, is it slide 12?
Yeah.
Now we do, yeah. So you really have to select each time the slide.
One by one. I think I should select one by one.
Please.
Is it okay?
It's okay now. The black footprints are
What
there.
about now?
So we can see the black footprints left by the bats.
So what about the floor of the cave? So the deposits are diverse in the floor of the cave. Three types of deposits are distinguished. There are coarse deposits, fine deposits, chemical deposits. So let's start by the course of deposits. These deposits formed usually with cubic forms and angular fragments in different size. And the arrangement and thickness of this block or fragments suggests an important lapse phase of the cave ceilings and walls. We pass now to the second type, the fine deposits. The fine deposits are rare and limited in the cave. There are mainly located.
Move the slides again. Thanks.
There are, I said, the fine deposits are rare and limited in the cave. There are mainly located in three main sectors. The first one is the northeast part of La Galerie d'Entrée. These deposits consist of two clay and silt layers. As you see in the table, so the X-ray diffraction of the samples. So the X-ray diffraction of the samples from two layers show a high proportion of clay minerals, and several other minerals such as quartz and calcite have been identified with a low proportion. That indicate that this deposits was formed by weathered cave ceilings in the long stable condition and also indicate that these deposits involve in confined environment or in confining conditions. What about now? It's okay?
Which slide do you want to show now? We're seeing the table. Yep, we can see a chart with a red line.
Okay.
The organic deposits in the Galerie de Bade.
Yes, yes, yes. There are also organic deposits accumulated specifically in the Galerie de Bade. The X-ray analysis shows that it's made mainly of candlelight, as you see. And in addition to candlelight, this analysis reports varying mineral of quartz and gypsum. These diverse minerals are formed by complex interaction between bath guano and limestone. And we have also gypsous saccharide deposits, which is accumulate in very, very specific layers or area in La Grande Salle, and which requires a detailed study. So let's move on to the next or the third type, chemical deposits or stalagmite deposits. So stalagmite deposits.
Move the slides.
So stalagmite deposits are very limited in the confined zone in Ralphie's cave. There are mainly accumulated in La Grande Salle. The uranium thorium dating of these deposits has made it possible to distinguish two generations of stalagmite. The first one is prior to Middle Pleistocene, and the second is from Middle Pleistocene to Holocene, exactly from this generation start to 478,000 years BP to 181 years BP. So let's talk now about the third one. So let's talk now about the third one, which is speleological phases of Ralphie's cave. So studies of Ralphie's cave also allow us to distinguish between two speleogenesis phases. The first one is a phreatic phase or submerged phase, and the second is the watering phase. Let's start with, or let's move to phreatic phase. There are many sedimentary and morphological cues which indicate the presence of this phase. We can note the predominance of capillus in the cave ceiling and walls, and then we can note also. We can note also the presence of the irregular shape of the walls and the insoluble parietal edges. Also, furthermore, there are the pebble-copper deposits are evidence of all deposits still present within the cave, and then the presence of a small lake in La Galerie d'Entrée. So the phreatic phase is followed by a dewatering phase. During this phase, the piezometric level of the submerged zone.
Move the slide?
Yes, I move it now. It's okay?
Yes.
Okay, wait. So I said the phreatic phase is followed by a dewatering phase. During this phase, the piezometric level of the submerged zone was lowered to their current depth. Speleogenesis cave in this phase is guided by three processes. The first one is chemical rearrangement process, which is characterized by a significant accumulation of collapsed blocks from the cave ceilings and wall. And the second is the chemical process resulted two generations of stalagmite. And the third one is the biological process associated with the presence of bats and their guano in cave. So you can see here the three effects of bats and their guano on cave ceilings and the floor. The first effect, respiration phenomena of bats. So respiration of bats can produce large amounts of carbon dioxide and water vapor, intervene to enhance the biocorrosion process. And the second effect is bat guano. So bat guano is a corrosive heat source that affects the cave floor through a complex biochemical process called fermentation. And the third one is the urine stream that affects directly the ceiling and walls of this cave. So at the end of this study, the speleogenesis of phreatic Paleokarst of Rihab cave was revealed to be much more complex than originally thought. This speleogenesis results in, first of all, abundant and diverse endokarstic forms and deposits. The second result is three types of morphogenetic process. First one, chemical process characterized by the construction and concretion. Mechanical process characterized by collapsed blocks, and geological process associated with the presence of bats. These three types of morphogenetic process are the origins of the decayed physiognomy. And the third result is different concretion and collapse generation. We identified two concretion generation alternated with collapse accumulation. And the last one is the different phases of the speleogenesis of this cave. We have the phreatic phases, which prior to Middle Pleistocene, and the watering phase start to Middle Pleistocene, exactly 478,000 years BP to or until now. So thank you so much.
Thank you so much for this amazing opportunity that you gave me to present my communication. My name is Dombo Haoumele. I'm coming from University of Chang in Cameroon. And my communication concerning the inventory of geomorphological factors and mass movement along the southern escarpment of Bamileke Plateaus, West Cameroon Highlands. I will use this outline to present the communication. I will start of all introduce, and then I'll present the methodology, and I'll present the result and interpretation and some discussion, and then I'll conclude. I will first of all say that the mass movement are natural hazards that generally affect by steep and unstable slope, which adequate lithological soils and geomorphological characteristics contribute to the hazard. Mass movements are generally constituted by subsidence, landslide, moss flood, rock fall, and landslide collapse. These mass movements are influenced by a number of conditioning factors, and these predisposing factors which add to triggering factors as rainfall and earthquake. Concerning the mass movement, concerning the study area, the study area is situated to the Bamileke Plateaus, especially to the northern part of Bamileke Plateaus, and it consists of escarpment, as you can see on this picture. Here is the study area, and this study area is have a lot of persons, and this person is always practice the activities. Here is the map of the study area. The southern escarpment of Bamileke Plateau is located to the southern continental branch of CVL, Cameroon volcanic line, between Bamenda region and Mount Maningumba mountain, and more than specifically between 5 degrees and 19 and 58.80 and to 5 degrees and 9 and 16.8 to the north, and 9 degrees to 57 to 43.2 and to 10 degrees to 18 and 10.80 to the east. These two figures show us the different relief of the study area, and you can see, like me, how this study area consists of an escarpment. So the aim of this communication is to give the relationship between the geomorphological factors and the mass movement along the study area. To attain this objective, we use this methodology. We first of all make the field campaign, and during the field campaign, we try to make the delimitation of the study area. We try to make the enumeration of the geomorphological factors, and we make the different mapping of these factors, and we make the mapping of the susceptibility to mass movement. This is the outline of mass movement susceptibility mapping procedure. You can first of all have here the mass movement inventory, the inventory of the mass movement, and then you have here the mapping of the different factors. As a factors, you have the slope direction, slope curvature, streams density, proximity to road, geomorphology, land use type, lithology, proximity to stream, and soil type. And I can make you know that concerning these different factors, we select only the geomorphological factors which affect the mass movement along the study area. Concerning the result of this communication, this image show us how much the study area is really affected by the mass movement, like a landslide. And this figure 5 is a movement density map of the different mass movement along the study area. This pink point, as you see here, is show us the different place of the landslide. This is the landslide, and the blue star here is the subsidence, and this yellow is the rockfall. We can find how the landslide is a major mass movement along the study area against rockfall and subsidence. The rockfall is just 5%, and the subsidence is just 5% against the landslide that is 19%. Concerning the different factors, morphological factors, we have this is the slope of map, and the steep landscape that have the slope between 27 and 18 degrees and occupy 5.25% of the study area. And concerning the slope of the slope direction map of the study area, the slope oriented to northwest occupy 14.89% of the study area. And concerning the map of the slope curvature of the study area, we have three types of curvature concerning the slope. We have the convex slope, which occupies 22.30%, and the concave slope occupying 17.87%, and the zero slope occupied 59.83%. So, concerning the geomorphological map of the study area, the moderate lands located, between 982 and 103 and 19 and occupied 23.17%. The upland that have elevation above 1,003 and 19 meter and occupy 25.59%. So this map is the mass movement stability map, which the vulnerability sits along the study area. And this table here, and this table here is show us the different percentage of the classes. We find that the low susceptibility zones occupied 16.95%, and the moderate 43.39%, and the high occupied 29.77%, and the very high occupy 9.89% of the study area. So we can just say that the majority of the landslides, for example, occur on the steep slope. The soil of this material has mobilized by this generally strong tendency for landslides to occur on the edge of road. The accessing of the probability of mass movement always involve conditioning. However, methods of its use is required to prior identification of the influencing of these factors. The aim of this communication was to give the relationship between the geomorphological factors and mass movement along the study area. The slope direction, The slope curvature and the relief is the major factors which involve the occurrence of the mass movement along the study area. The mass movement density map show that the landslide represents 19% of the mass movement in general on another mass movement like subsidence and rockfall. Yes, so we can say that this zones is majorly affected by the landslides. The slope is almost factors that the majority of mass movement are located on the higher slope. The susceptibility map of the mass movement is in the study area show that the high susceptibility zones represent about 29.77%. So thank you for your kind attention.
Good morning. Good morning from here in Ibadan, Nigeria. I have a few presentations, part of an ongoing work that we are doing with my unit here in the University of Ibadan. And the work is basically talking about the dynamics of riparian vegetation cover along the River Niger and River Benue using the GIS and remote sensing technique. Actually, what informed this study is because of the fact that the population. Hello, can you hear me? Can you hear me?
Can you put it in full screen mode?
Full screen mode.
Yeah.
While like this.
Yes, it is clear.
Is it okay? Okay. Now, what informed this study is that the population of Nigeria and Africa as a whole is increasing, and humans are looking for where to live and also to have carry out their daily activities and to sustain their livelihood. But something is happening along the major rivers of Nigeria and even the smaller rivers. And what is happening is the depletion of the riparian vegetation. I tried to make a definition of what the riparian vegetation is, and it's all about the flora communities, the habitats that domicile the river corridor or the margins of rivers. It's a very wonderful ecotone with diverse ecological importance that gives the role, an essential role of stabilizing and maintaining the river ecosystem. It's the riparian vegetation is very, very important, but in the African setting, it's not, people don't know the value that should be accorded to this precious ecosystem. It's really experiencing disturbances, and there are a lot of degradation happening along the riparian vegetations that we have in Nigeria. And because of this, I try to make the major contribution of what the riparian corridor seeks to promote. And we can see that it supports biodiversity, rich biodiversity, maintains the microbes, both the fauna and the flora, and it's an ecosystem that should be managed and maintained and sustained. The aim of this study is to evaluate the dynamics of the riparian cover of River Niger and Benue between 2000 and 2020. And I tried to make a map of just to extract the map of River Niger and River Benue. Actually, these are the largest river that we have that drains the major landscape of Nigeria. River Niger takes its source from Futa-Jalon Island from Guinea, and before coming down to River Niger, and coming down to Nigeria, where it has a significant use. And of note is the confluence, where they met with River Benue that takes its source from some island from Cameroon, and they met in the confluence at Lokoja. This is a map that tries to show the basin that surrounds both River Niger and River, and you can see there are a lot of rivers, smaller rivers that drains into the river. So the River Niger and choosing River Niger and River Benue as the major study site for this presentation is very, very of utmost importance. What method I use is that since we want to know the study period between 2000 and 2020, I made some image classification using the GIS techniques and using the Google Earth Engine platform by using the random forest machine learning algorithm. For the climate parameters, mainly the rainfall and the temperature was sourced from the climate hazard group infrared precipitation with stations data. That's the STRIPS data that was used to get the time series analysis done in the Google Earth Engine platform. And those images were imported to TerraSet to calculate the changes in the riparian vegetation, and were able to determine the gains and the loss that are attributed to the riparian vegetations of the River Niger and River Benue. So for the result, the major factors that informed the dynamics, definitely the riparian vegetation zone of River Niger and River Benue had been changing their dynamics in it. And what really I was able to find out that climate plays a significant role, and even anthropogenic forces has a significant impact on the dynamism of the riparian vegetation. So the salient considerations of findings in this study is that the riparian vegetation zone that was used for this study was basically an extent of 10 kilometers, both the right and the left side of the river. And we were able to see some significant changes along the study river owing to the exploitation of the riparian zone, and because of the constant availability of water even during the dry season. And the trend analysis of rainfall and temperature reveals significant increase in temperature. So also, and there was a significant decline in vegetation, the riparian vegetation. This was revealed by the NDVI analysis. While the floodplain, we could see that floodplain agriculture dominates the riparian zones, accounting for the anthropogenic factor. Now, for the climate indicators, temperature and rainfall, we could see that the temperature has been increasing during the study period from year 2000 to 2020. And in fact, it's significant. The trend analysis shows that between those two rivers, the temperature had been increasing, and this we can confirm that with some form of the activities that are taking place, and it's very, very hot. Even at this time, the temperature is something like 38 degrees C. Also, the precipitation has been fluctuating, and of note is the year 2012 towards 2012-14 that the precipitation went down a bit, but now it's increasing, but not as before. If we take some slices back to like 1970, 1960, 1980, you could see that the rainfall had always been on the high side during those period. For the NDVI analysis, we can see that the vegetation of the riparian zone has been going down. It's been depleted, and statistically, we can see that it's going down with the values of the R. Now, the sense slope that was done to quantify the magnitude of the time series trend in the riparian vegetation condition, and we could see that the peak, the crest of the sense slope, we can see it at the negative section for both River Niger and for River Benue. This is confirming the fact that the vegetation is reducing, is being depleted. Now I took some slices of the riparian, as like I said, 10 kilometer area was delineated for the riparian zone of this study. And we could see different classes of land use, land cover within this environment. We could see that this is narrowing down on the Lokoja section, and we could see the various land cover that inside the place. We have a built-up area, riparian zone, and the likes of that. Now, this is another session. I picked some sessions from River Niger and the middle one, and also some sessions on River Benue. In all, one can see that the riparian vegetation has really gone down in its cover. I mean, the riparian cover has gone down between 2000 and 2020. Not to talk of if the analysis has been between 1984, we'll see more of the drastic changes that is happening to the riparian cover of the along the River Niger, River Benue. Which of note is that this river is the largest river that traverses or that drains the whole of Nigeria. So we can see that the losses for about the right showcases that about 4,592 square kilometers of kilometer square had been lost to different activities and climate change. Now, what are the activities contributing to this riparian loss? We have more of the riparian, more of floodplain farming has really contributed to the loss of this cover that we found at the preceding slide. And we could see that within the riparian vegetation, the floodplain agriculture, floodplain farming, and there are other activities taking place. We can see that sand mining is coming up too, but mainly floodplain agriculture can be attributed to the loss that we have within the study regions. And I have some photos of some of these agricultural activities. You can see this is a plantation within practices along the floodplain of River Niger. And this is an area view along, this is immediately after the Kanji Dam, we have some activities of plantation. You can see it's organized and tapping through that area to make use for agricultural activity. Now you can see picture of farmers working along the riparian zone trying to, farm. And this area, this photo is specifically showing an area that had been degraded, that had been in the riparian zone along River Niger that had been degraded. And you can see pockets of trees that colonized the area before, but now giving way to for human habitation. That is what is reflected in the built-up area that we have in the map analysis that was done. You can see different activities taking place, and the area is now devoid of the usual vegetation that was there before. Now, in conclusion, we can say that there are fluctuations in rainfall and temperature, and this has really influenced the hydrology of the river, which has impacted the riparian vegetation, causing these dynamics. And also there are interactions between riparian vegetation conditions and climatic patterns. the losses in the riparian corridor of the study river is greater than the gain. As shown before, there is this severe depletion in the riparian corridor, and the riparian corridor of River Niger and Benue are mostly dominated by floodplain farming. But the main activity farming that is being practiced there is the growing of rice and some barley and some other millets. Those are the main activities of farming that takes place in the area. So the recommendation is that anthropogenic disturbances of riparian corridors should be discouraged along rivers to mitigate against the impact of climate change, and the body that is saddled with the management of rivers, that is the River Basin Development Authority, should be able to impact and impact and implement the policies that are related to the management of the riparian environment to avoid over-exploitation of this precious ecosystem. Thank you.
Thank you, Zengamo, and thank you for AIG for host us. First of all, hi everyone. It is my pleasure to be here. Welcome all. My presentation will be evaluation of low-cost drones in mapping underwater geomorphology of Fentas Beach in Kuwait. My name is Ahmed Hassan. I'm a teacher of geomorphology in Faculty of Education, Matruh University in Egypt. First of all, my presentation will be in 7 points. Number 1, introduction. Number 2, case study and coastal problems in Kuwait. Number 3, methodology and aims. Number 4, coastal geomorphology of Fentas Beach. Number 5, drone surveying. Number 6, a protection plan for the beach from storm waves and sea level rise. And conclusion, number 7. Introduction. In general, the state of Kuwait is in the northwestern corner of the Arabian Gulf. Here, as we see, Iran beside Kuwait, and Iraq and Saudi Arabia. So it's bordered by Arabian Gulf from the east and Iraq from the north and west, and by Saudi Arabia from the south. The summer of Kuwait is very dusty and very hot, with a maximum mean temperature about 45 Celsius. Whereas its winter is warm, with an approximately area about 18,000 square kilometers. In general, the Kuwaiti mainland is characterized by low relief, the higher elevation in the west, about 300 meters, and its winter is hot or warm, and the annual precipitation about 125, as we see in the chart. Introduction, Kuwait faces many environmental challenges in the 21st century. These challenges require that researchers and decision makers confront the speed of action to protect the environment. In this regard, geomorphology and GIS and also remote sensing comes as an effective tool to provide spatial analysis to help the decision maker to confront the climate change and its result in ways that preserve the sustainability of ecosystem. And by the way, this paper extends with another paper published in 2020. It's entitled Potential Impact of Sea Level Rise on the Geomorphology of Kuwait State Coastline. We prepared a vulnerability index for Kuwait based on modeling, as we see, 5 criteria for modeling coastal area, elevation, surface sediment, geomorphology, slopes, and also land use. To make this layout, to know which low in vulnerability to sea level rise and which the place is moderate and which one is high. This is a criteria of the methodology. After the modeling, the impacts may involve 5 things. Number one, expanding Sabakhas area. Number two, shoreline retreatment and loss of sandy beaches. Number three, changing coastal hydrodynamics pattern. Number four, accelerate weathering mechanisms. Here our methodology depends on drone from DJI Mavic Air 2 and Trimble R8 to make our surveying more accuracy. Our aim is to studying coastal geomorphology of Al-Fintas Beach, and number two, proposing a protection plan for the beach from storm waves and sea level rise. Result and discussions, coastal geomorphology of Al-Fintas Beach to understand a geomorphology, general geomorphology of the coastline. Here we can see a satellite image showing the landforms on the beach. This is in 2010. As we can see, before construction in 2010, as we can see, natural processes dominate the beach, and there is no human effect in the beach, only sandy plain and ancient tombs, as we can see, and beach. Natural geomorphology dominates the beach. And then after infrastructure and making some installation besides the coastline, like children play area and 4 playgrounds, all beside the coastal road, and historical tomb, and coastal walkway, and full playground, and open air gym. All this infrastructure beside the wall, beside the sea, without any protection from the waves to the infrastructure. This is what's happened in 2014 after storm waves. It's destroyed the walkway and destroyed some of infrastructure besides the sea, as we see in this image. And also in 2019, we have another phase of destroying of the coastline and the infrastructure. Storm waves attacked the beach and destroyed some of the infrastructure. Also, in 2021, a storm waves comes again and destroyed the beach. This is a close-up drone image, of one of Ocean Bay in Fintas Beach, showing the infrastructure in the beach and the area affected by storm waves and sea level rise. Here we can see a clear small bay and the coastal walkway and the destroyed area in this place. Next point, coastal surveying by DJI Mavic Air 2, and here we have all details about the mission which did by Mavic Air 2. All details, total distance, number of photos, total time of surveying, max speed, altitude of the drone, and also the video capture. Here we have some layouts of the surveying. In the left side, we have mosaic from 134 image from drone to make ortho image or mosaic for the beach. And here we have M or digital surface model to know where the best or the right place to put the protection of the beach from the storm waves. Here we have some underwater geomorphology of the shallow water beside the coastline. As we see, through drone image, we can survey the shallow water. As we can see here, a good idea of landforms in sea floor to put the protection of the beach on the right place. As we see, we can see good underwater ridges, sand deposits, coral reefs, and also micro depression here. And ridge 1, ridge 2, you can see very well the surface or the underwater geomorphology of the sea. A protection plan for the beach from storm waves and sea level rise. The protection plan here relies on 3 barriers, as we can see, barrier number 1, 2, 3. 3 barriers that can far from the coral reef to protect it, and open to allow, open as we see, we have open from this place and this place, as we can see, to allow the water quality and the current to a good move beside the coastline. Conclusion, beach data are usually used for estimating shoreline dynamics and beach morphology. Different parts of Kuwaiti coastal area have been experiencing varied rates of erosion. For example, it was estimated that during the period of 2016 to 2019, the erosion rate at Marina Beach and Blajat Beach, both are famous beaches in Kuwait, the rate was from 7 to 10 meters per year. While the northern beach in Kuwait, acceleration rate about 4 meters. Generally, sea level rise and storm waves also will accelerate erosion in Kuwaiti sand beaches, which are generally characterized by a gentle slope about 7.5 degrees on average. So drone help provides a high accuracy and low cost database such as aerial photography, ortho image, digital surface model or DAM, digital surface model, or the digital elevation model, and also point cloud that can be used to protect the coastal area from storm waves and changes in sea. It is necessary for the government of the state of Kuwait to make an urgent plan to protect the beaches and infrastructure from the environmental changes that occur from the storm waves in the winter season and from sea level rise in this century. Thanks. Thank you, my friend. Thank you all.
Okay, I am Chibo Christian Nambi. I'm presenting on a spatial assessment of Gully, spatial assessment of variation in Gully morphological parameters across land cover and the ecological units of Upper Imo River in southeastern Nigeria. We know that Gully erosion is one of the most geomorphic hazards in Upper Imo River basin, because according to so many research that has been carried out in the area, the entire southeastern Nigeria has been ravaged with this environmental problem. And the consequence of this problem is as a result of interaction between man and the environment. Several research carried out on this gully in various parts of the world indicated that gully erosion has been identified in almost all the climatic zones of the world. So, the resultant problem of gully erosion include the change in landscape morphology, soil removal, and sediment deposition. To buttress more on the how serious gully erosion is ravaging the southeastern part of Nigeria. Study carried out by Ebuka in 1970 indicated that over 1,970 gully sites have been identified only in Imo and the Anambra states, and over 2,500 active gully sites have been observed only in Imo State. And the study carried out by Opomata in 1975 showed that about 1.6% of the entire southeastern Nigeria is occupied by gully erosion. And there's also a strong relationship has also been found between gully development and lithology. Gully development, lithology, and land cover. And this study centered more on analyzing and studying, identifying the variations that exist in gully morphological properties in land cover and lithology of Upper Imo River basin. So the aim of this study is assessing the variation in gully morphological variables across the land cover and lithological units of Upper Imo River Basin. And the major objective is to document and assess land cover change in Upper Imo River Basin, and also to assess the variation that has existed in gully morphological properties across land cover and lithology of the study area. The study area is Upper Imo River Basin, which can be seen in the map, and the study area is located between latitude 5 degrees and 6 degrees north, and longitude 6 degrees and 8 degrees east of the Greenwich Meridian time. The topography of the area is purely plain topography, and the Imo River Basin is the major river that drains the study area, and the lithology of the area, as identified, is classified into 4, which is the first bedded limestone, coastal plain sand formation, the lignite, and the Bendameki formation. The methodology: reconnaissance survey was carried out first for the researcher to acquaint himself about the gully status in the area. And this reconnaissance survey was carried out between 2007 and early 2019. The standard field measurements was used to obtain the gully morphological parameters of the smaller gullies. That is, those gullies that are still at the initial stages of development. While topographic map, sheet 302, and the Landsat imagery, Landsat 8, was used to obtain the morphological parameters of larger gullies, those gullies that have gone so wide that field measurements, ordinary field measurement using tapes cannot be used to obtain their morphological properties. And also land cover analysis was done to determine the extent of land covers in those areas, and also to know the extent of these land covers, the land covers identified, to know their area coverage. Results and discussion. After analysis, the research was able to identify 5 major land covers in the study area. And these 5 major land covers in the study area have changed over the time between 2003 and 2018. The greatest change in the land cover was obtained in the built-up area. And let me just identify that the 5 major land covers identified in the study area, the built-up area, the forest cover, the wetland, the water bodies, and the farmland. And the greatest gain in the land cover that was obtained in the study area within the period was seen in the built-up area, which gained about 565.8 square kilometers, or about 6.99% of the entire land cover. And the greatest loss, and the land cover that has the greatest loss in the study area was farmland, that lost about 1,036 square kilometers, or about 12.79% of the entire land mass. And the implication of this increase in built-up area and reduction in the forest vegetation is that more land in the study area has been exposed, or is still being exposed to gully in the study area. The information presented in figure 3.1 shows the change in land cover of the study area between 2003 and 2018, and also the area coverage of this land cover in 2003 and also in 2018. Then we went further to know the variation that has existed in these gully morphological parameters across land covers. We were able to find out that the highest mean gully length, because the gully morphological parameters that we studied were the gully length, the gully width, the gully depth, and the gully area, because these are the most popular study parameters, gully morphological parameters observed in the literatures reviewed during the course of this study. And we were able to observe that the highest gully length obtained in the study area was found in the built-up area, which is about 99 meters, while the least gully length was found in water bodies, which is 60.02 meters. We also went further also to talk about the spatial pattern of these gullies across the study area. And we were able to find out that to also know how these gully morphological variables were distributed in the lithological formations of the study area, where we were able to find out that the total gully, the entire gully length of the entire length of the total gully studies, which are about 18 in number, were 6,102 meters, and the total width was 2,083 meters. The area was 330 square kilometers. And of this value, the total gully length obtained in the coastal plain lithology, which is one of the lithologies identified in the study area, was 4,390 meters, which means that the coastal plain sand lithology in the study area took about 71% of the entire gully length in the study area. While, and also, it also took about 78% of the entire gully width, and about 79% of the entire gully area. For lignite geology, lignite lithology, which was also one of the gully, was also one of the lithology that was affected by gully. I also need to emphasize here that out of the 5 lithologies that were identified in the study area, it was 3 of them that were affected by gully. The other 2 were not affected by any gully. So for lignite lithology, the total gully length that was found here was 1,157 meters, which means that it took about 19% of the entire gully length in the study area. And there are about 22% of the entire gully length of the study area. And there are about 20.5% of the entire gully area in the study area. The next lithology that was affected by gully in the study area was Imo Glacier. This Imo Glacier has occupied a total gully length of 565 meters, which is about 9% of the entire gully length. The width was 10.5 meters, which is about 10.5 meters of the entire gully width in the study area. And the area was 1.32 square kilometers, which is about 0.5% of the entire gully, of the entire area occupied by gully. So what we are just trying, what the result of the research was able to find out that among the 3 lithologies that were affected by the gully, that it was the coastal plain lithology that was the most vulnerable lithology in the study area, because it occupied about more than 70% of the gully morphological parameters studied. So in conclusion, the research was able to identify 5 distinct land covers between 2010 and 2018. And all the identified land covers experienced changes, though some of them experienced positive change and some of them experienced negative change. And water body, wetland, and built-up areas were the land covers that experienced gain, while the forest and farmland were the land covers that experienced loss. 5 lithological units were also identified, and 3 out of the 5 lithological units were attacked by gully. And the research identified that coastal plain sand is the most vulnerable lithology that has gully attack, since it occupied more than 70% of all the gully morphological parameters in the study area. Thank you very much.
D'abord, je tiens à remercier les organisateurs de ce webinaire qui m'ont présenté plusieurs sujets traitant de la géomorphologie en général.
Merci. Allez-y. Mr. Kwame. Oh. We lost.
Allô?
Yes.
Ok, c'est bon maintenant?
Oui, il faut repartager votre écran.
D'accord. Je crois que maintenant ça peut aller. Je peux avancer?
Oui, allons-y, c'est bien maintenant.
D'accord. Comme je le disais, ma présentation va porter sur l'évaluation des risques côtiers sur le littoral kétalonais en utilisant l'outil Kosa Haza Well.
Oui, allons-y. Est-ce qu'il y a un souci?
particulier.
Oui, oui, j'ai un...
On peut vous aider à quelle échelle?
Oui, bon, je ne sais pas si... Oui, non, vous n'avez pas avez-vous la possibilité de définir les slides? J'ai l'impression que ma machine est en train de...
Bon, quittez un peu le mode full screen.
Mais normalement, si vous cliquez sur la présentation lui-même, vous pouvez ensuite avancer. Voilà.
Ah, d'accord, c'est bon. Voilà,
ça marche. Merci.
Ok, donc ma présentation suivant le plan que voici. D'abord une brève introduction. Ensuite, je vais présenter les objectifs de l'étude, la méthodologie, les résultats, les options, les propositions d'aménagement et une brève conclusion. Alors, pour commencer, il faut souligner que la majorité des côtes au niveau mondial fait face aujourd'hui à de forts aléas tels que l'érosion côtière, les submersions et l'intrusion saline dans les systèmes côtiers. Alors, les hommes, au cours des différents siècles, ont semblé ignorer ces différents aléas, et ce qui amène aujourd'hui à exposer de nombreux enjeux à ces différents aléas et qui entraînent de nombreuses conséquences également sur l'économie et surtout les sociétés qui sont installées dans les zones côtières. Alors, les prévisions d'évolution du climat en termes d'élévation du niveau marin constituent des facteurs aggravants pour ces aléas côtiers qui impactent les enjeux en milieu côtier. Alors, cette problématique menace également notre zone d'étude qui est le littoral qui s'étend de Keta au Ghana jusqu'à Lomé au Togo. Alors, la zone d'étude appartient au géosystème Volta-Mono et qui s'étend de Keta, comme je le disais, au port autonome de Lomé au Togo. Et elle couvre, la zone d'étude couvre une distance de 40 km. Cette zone fait face aujourd'hui à une forte érosion dont la vitesse est mesurée à plus de 10 mètres par an sur les segments les plus sensibles. Alors, déjà, nous voyons des images ici qui illustrent la vélocité de cette érosion qui endommage et détruit beaucoup d'infrastructures, beaucoup d'habitations au bord, en bordure de mer. Alors, cette forte érosion expose également les enjeux côtiers aux différents risques tels que les submersions marines, l'intrusion saline dans les systèmes côtiers, les rivières et les sols, et les inondations graduelles. L'objectif principal de cette étude est d'évaluer en fonction de la dynamique morpho-sédimentaire des segments côtiers, le niveau de risque des différents aléas côtiers qui ont été identifiés et qui impactent les enjeux humains, économiques et environnementaux sur notre zone d'étude. La méthodologie utilisée est celle du constat hasard-wheel, qui est un outil développé par ONU Environnement qui permet d'évaluer de manière qualitative les différents aléas, le niveau d'impact des différents aléas côtiers sur les enjeux en milieu littoral. Alors, le système est organisé autour de plusieurs auréoles qui définissent les paramètres utilisés. Nous avons la configuration géologique, l'exposition aux vagues, le marnage, le marnage, ces paramètres permettent d'identifier les aléas de la faune et la flore, tels que la perturbation des écosystèmes, les inondations graduelles, l'intrusion saline, l'érosion côtière et les submersions. L'outil présente en soi, à la fin, un modèle de gestion qui offre des options de gestion selon les différents aléas et la gravité de chaque aléa. Donc, la mise en œuvre de cet outil est basée sur le logiciel ArcGIS. Il y a une manière de procédure qui permet de suivre différentes étapes à travers le logiciel ArcGIS pour pouvoir identifier et évaluer le niveau des différents aléas, le niveau de risque des différents aléas identifiés dans la zone d'étude. Alors, quels sont les paramètres utilisés dans cette présente étude? Alors, nous avons utilisé la configuration géologique. Il faut souligner que notre zone d'étude est une côte basse, une côte sableuse très basse et dont les altitudes n'excèdent pas 5 mètres. Donc, c'est une côte très basse parsemée de marécages et de cordons sableux côtiers. L'équilibre sédimentaire, comme je le soulignais plus haut, est marqué par une forte érosion. Et le traitement des données a permis de segmenter notre linéaire de côte en plusieurs petits segments. Donc, vous allez voir ici, nous avons le segment GA1 jusqu'au segment GA4 qui concerne jusqu'au segment GA5 qui concerne la côte du Ghana, G2 qui concerne la côte. Nous avons pu identifier les zones où l'érosion est assez forte, les zones où l'érosion est assez modérée, les zones de sédimentation et les zones où l'érosion, on a une alternance d'érosion et de sédimentation. Le deuxième paramètre utilisé, c'est l'exposition aux vagues. Ici, nous avons utilisé les données de vagues et de houles mesurées de 2003 jusqu'en 2012. Et nous avons essayé de caractériser ces différentes données de vagues qui nous a permis d'identifier la force des vagues dans notre zone d'étude. Ainsi, nous avons pu identifier que la période des vagues aussi entre 10 et 10 secondes, la direction est de sud-sud-ouest et la hauteur des vagues varie de 1 à 2,8 mètres. En termes de marnage, notre côte est une côte exposée à un marnage semi-diurne, c'est-à-dire une alternance de haute et de basse marée 2 fois dans la journée. Et l'amplitude de la marée évolue entre 1 et 1,5 mètre. Alors, quels sont les résultats auxquels nous sommes parvenus? En ce qui concerne l'érosion côtière qui constitue l'aléa majeur sur notre zone d'étude, nous avons pu identifier que la zone GA3 qui se trouve sur la côte ghanéenne représente le segment le plus exposé, le plus vulnérable à l'érosion côtière. En effet, ce segment se trouve juste en aval d'une série d'ouvrages de protection qui amplifient en aval la force des vagues qui s'attaquent à ce segment. De même, deux segments modérés ont été identifiés, le GA1 et le TG1. Les deux segments sont identifiés comme des segments à risque élevé à l'aléa d'érosion et nous avons également un dernier segment qui présente des Nous avons un dernier segment. Excusez-moi. Voilà, nous avons deux derniers segments qui présentent un risque élevé à l'érosion côtière. En ce qui concerne les submersions, nous avons identifié la zone juste en aval des ouvrages de protection, les deux segments GHA3 et GH4 comme des zones, des segments à risque très élevé en ce qui concerne les submersions. Et de l'autre côté, en ce qui concerne les submersions marines, nous avons pu identifier toujours la zone GA3 qui se trouve juste en aval des ouvrages de protection, comme la zone exposée, dont l'exposition est assez forte au risque d'inondation graduelle. Voilà. En ce qui concerne les intrusions salines, le risque évolue de élevé à très élevé, puisque nous sommes sur une côte très ouverte, très basse, ce qui fait que la force et l'introduction des masses d'eau marine dans le système côtier est assez importante, ce qui fait que toute la côte est exposée à un niveau très élevé à ce risque. Alors, quelles sont les options d'aménagement que l'outil permet d'identifier par rapport aux différents risques exposés? Ici, après analyse et croisement des données, l'outil a permis d'identifier une option unique d'aménagement face à ces différents risques, qui est la construction des digues. Donc ici, nous vous présentons une illustration d'image de digue que l'option permet, ou bien l'option suggère, l'outil suggère de pouvoir mettre en place pour lutter contre ces différents aléas côtiers. Alors, en conclusion, nous dirons que en fonction de la nature sableuse et de la structure de côte très basse de notre zone d'études, l'érosion côtière a été identifiée comme l'aléa majeur qui impacte les enjeux dans notre zone d'études. Également, nous avons pu identifier que sur les segments où l'équilibre sédimentaire est négatif, c'est-à-dire les segments exposés à une forte érosion, les autres aléas également présentent des niveaux de risque d'élevés à très élevés. Et de l'autre côté, les segments de côte qui présentent un équilibre sédimentaire, je dirais, modéré ou excédentaire, présentent de leur côté des risques présentent des niveaux de risque par rapport aux autres aléas qui évoluent de modéré à très faible. Par contre, l'aléa d'intrusion marine et d'intrusion saline dans les systèmes côtiers présente sur l'ensemble de nos zones d'études un fort niveau de risque par rapport aux autres aléas. Merci pour votre attention.